My dear students and parents, in this video we are going to do a word problem in the multiplication of matrices, and we are going to find the total sale amount in the chapter matrices in the subject mathematics to the +2 Cbse students. By God's grace, my educational videos are available in YouTube to 10th Cbse, +1 Cbse, +2 Cbse, NEET and IIT students in the subjects mathematics, physics, chemistry, zoology and botany in English language. Let us see the sum. A manufacturer sells the products X, Y, Z in two markets. Annual sales are indicated below. Market products. In the market 1, the products sold are 10,000, 2,000, 18,000. In the 2, the products sold are 6,000, 20,000, 8,000. Question A. If unit sales prices of X, Y and Z are rupees 250, rupees 150 and rupees 1 respectively, find the total revenue in each market with the help of matrix algebra. Question B. If the unit cost of the above three commodities are rupees 2, rupees 1 and 50 paise respectively, find the gross profit. In the question, it is mentioned that there are two markets, market 1 and market 2. In these two markets, 3 products are sold. What are that 3 products? That 3 products are X, Y and Z. They have given the number of products X, Y, Z sold in each market, and also they have given the unit sales price of the products X, Y and Z. From these two information, we can calculate the total sales amount of products X, Y, Z in the market 1 as well as in the market 2. In this sum, we are going to do the sum using the matrix algebra. Matrix chapter, we are studying equality of matrices, types of matrices, order of a matrix, addition of matrices, difference of matrices, multiplication of matrices, multiplication of a matrix by a scalar, transpose of a matrix, inverse of a matrix using elementary operations, and also special matrix operations, that is symmetric matrix and skew symmetric matrix. In this video, we are going to discuss the multiplication of a matrix topic. In order to calculate the addition of two matrices or difference of two matrices, the order of two matrices should be equal. In this case, this is not so. Matrix representing the sales of 3 products X, Y, Z. The matrix A, we are taking the number of products sold in the market 1 and 2. That is, the products are X, Y, Z. The number of products sold in the first market is 10,000, 2,000, 18,000. The number of products sold in the market 2 is 6,000, 20,000, 8,000. Then we are writing the matrix denoting the sale price of one product. The matrix B equal to the selling price of each product X, Y, Z. The selling price of one product X is 250. The selling price of one product Y is 150. The selling price of one product Z is 1 rupee. The total revenue, that is the total sales amount in the products X, Y, Z are, that is the multiplication of the matrices A, B. It is written as, in the first matrix, the products of X, Y, Z, the number of products sold are written, that is 10,000, 2,000, 18,000, 6,000, 20,000, 8,000. Here the matrix B is taken, that is the unit price of the products X, Y, Z are taken, that is rupees 250, rupees 150, rupee 1. The order of this matrix is, that is the matrix A is 2 by 3. The order of the matrix B is 3 by 1. After multiplying these two matrices, we will get the matrix of the order of 2 by 1. The reason is 2 by 3 and 3 by 1. This 3 and this 3 will be cancelled. Thereby, we will get the order of the matrix after performing the multiplication of matrices as 2 by 1 matrix. In order to find the multiplication of two matrices, two conditions should be satisfied. The one condition is, if we take two matrices A and B, in order to find the multiplication of these two matrices A and B, the number of columns of the matrix A should be equal to the number of rows of the matrix B. Condition for multiplication of two matrices A and B: the number of columns of matrix A should be equal to the number of rows of matrix B. Then how can we get the value of product? We should take at a time one row and one column. The first element of the row should be multiplied with the corresponding first element of the column. Then the second element of the row should be multiplied with the corresponding second element of the column. The third element of the row should be multiplied by the corresponding third element of the column, so that we will get the product. These all products should be added. In the previous videos, we have studied this fact without understanding the exact meaning. But in this video, we can understand the clear meaning why we are multiplying in such a way in order to get the multiplication of two matrices. Because in this video, we are doing the word problem. That is the number of products sold and the unit price of each product has been provided. So if the number of products is multiplied by the unit price of the product, we will get the total selling value of that product, so that we can understand the meaning very well. In this sum we will see that fact. The second condition, elements of product are obtained by multiplying each row of a matrix A with each column of matrix B element wise and adding them. The multiplication of two matrices AB equal to, the products are X, Y, Z. There are two markets, market 1 and market 2. In the market 1, the number of X products sold are 10,000 numbers. The number of Y products sold are, the number of Z products sold are 18,000 numbers. In the market second, the number of X products sold are 6,000 numbers. In the market 2, the number of Y products sold are 20,000 numbers, and the number of Z products sold are 8,000 numbers. This is the unit price of X product. This is the unit price of Y product. This is the unit price of Z product. In this case, what are the number of columns? The number of columns are 1, 2, 3. In the case of matrix B, what are the number of rows? First row, second row, third row. There are 3 rows. So, as per the first condition, the number of columns are 3 and the number of rows are 3. So, the first condition is satisfied. Since the number of columns of a matrix is equal to the number of rows of another matrix, we can multiply these two matrices, though thereby we will get the multiplication of the matrices. In this case, it is possible. As I already told, at a time we should take one row and one column. That is, we are going to take the first row of matrix A and the first column of matrix B. It is written here, first row of matrix A. This is the first column of matrix B. If we multiply, that is the first element of this row with the first element of this column, we will get 10,000 into 250. That is 10,000 number of X products are sold. The unit price of X product is 250. So that if we multiply the number of products with the unit price, we will get the total sale value of this product X. Similarly, if we multiply the second element of 2000 numbers with the corresponding second element of this column, that is rupees 150, we will get the total selling value of Y product. That is 2000 into 150. So we have obtained the sale value of X product and the sale value of Y product in the case of market 1. Now we have to find the sale value of Z product in the market 1. If we multiply the third element of this row with the corresponding third element of this column, we will get 18,000 into 1. That is, 18 numbers of Z products are sold in the market 1. The unit price of one Z product is rupee 1. Therefore, if we multiple 18,000 into 1, we will get the sale value of Z product sold in the market 1. Then 10,000 into 250, 25,000 plus 2,000 into 150, 3,000, 18,000 into 1, 18,000. We should add all these multiplication so that we will get the product value. So here also it is mentioned, we should add in them. 25,000 plus 3,000 plus 18,000 equal to 46,000. It is the total sales amount in the market 1. Into the market 2, the number of X products sold are 6,000 numbers. The number of Y products sold are 20,000 numbers. The number of Z products sold are 8,000 numbers. The unit price of X, Y and Z products are same. That is, the unit price of X product is 250, the unit price of Y product is 150, the unit product of Z product is 1. We are taking this second row and this first column, that is second row and the first column. So as we already performed in the market 1, here also we are going to multiple the first element of this row with the corresponding first element of this column, so that we will get 6,000 into 250. Then we are going to multiple the second element of this row with the corresponding second element of this column, so that we will get 20,000 into 150. Again, we are going to multiple the third element of this row with the corresponding third element of this column, so that we will get 8,000 into 1. Then we should add all these products. 6,000 into 250, 15,000 plus 20,000 into 150, 30,000 plus 8,000. So we will get the total sales amount of market 2 as 53,000. So 46,000 is the total selling value of market 1. The 53,000 is the total sales amount of market 2. My dear students, in this problem, since the number of products sold and the unit price of each product have been provided, we can clearly understand the concept of multiplication of matrices. If this video is most beneficial to you, you can share this video with your friends and classmates. You can also subscribe my channel. If the students want to know all the information of this chapter, I appeal to the students to see all my videos. My dear students and parents, in this video we are going to prove that the commutative property and the associative property are satisfied in the given multiplication table. In the chapter Relations and Functions, in the subject Mathematics to the +2 Cbse students. By God's grace, my educational videos are available in YouTube to 10th Cbse, +1 Cbse, +2 Cbse, NEET and IIT students in the subjects Mathematics, Physics, Chemistry, Zoology and Botany in English language. The question is, consider the binary operation on the set 1, 2, 3, 4, 5 given by the following multiplication table. The question number 1, compute 2 binary operator 3, binary operator 4 equal to 2 binary operator 3 binary operator 4. Second question is binary operation is commutative? 3. That is third question. Compute 2 binary operator 3, binary operator 4, binary operator 5. The multiplication table is also given. We know that the multiplication table is also called Cayley table because Cayley described this table. What is commutative property? If we interchange the order, that is the position of the numbers, the result should not be changed. For example, if we take the number 2, we are adding 3 with this number, what result we will get? The result we are getting is 5. Similarly, if we add 3 with 2, here also we will get the result as 5. In this equation, we are interchanging the order, that is position of the numbers. In the place of 2, we are writing 3, and in the place of 3, we are writing 2. It means that we are interchanging the numbers. 2 is interchanged as 3 and 3 is interchanged as 2. Even though they are interchanged, the result is not changed. The result is same. Therefore, we confirm that in the case of addition operation, the commutative property is satisfied. Let us see the multiplication operation. We are taking the number 2. That number 2 is multiplied with 3. We will get the result as 6. In the place of 2, now we are writing 3. In the place of 3, we are writing 2. It means that we are interchanging the numbers 2 and 3. So if we interchange the numbers, here also the result is 6. Even though we are interchanging the numbers, the result is not changed. The result is the same. So that in the case of multiplication operation also, the commutative property is satisfied. So we can conclude that in the case of addition operation and in the case of multiplication operation, commutative property is satisfied. Then we are going to discuss the associative property. What is associative property? In whatever way the given numbers are grouped, the result should not be changed. That is, the result should be the same. Wherever we put the parenthesis, that is bracket. For example, we are adding 2 with 3. After adding 2 with 3, we are adding 4. 2 plus 3 equal to 5. Then if we add 4 with this 5, we will get 9. In the first case, we have grouped the number 2 with 3. Then we add the number 4. In the second case, we are grouping the numbers 3 and 4. After adding these two numbers, we are adding 2 2 with the result. If we add 3 and 4, what result we will get? We will get the result as 7. After getting the result, if we add 2 with this 7, the final result is 9. Here also we are getting the result in 9. Here also we are getting the result in 9. So the result is not changed. In whatever way we are grouping the numbers. In the first case, we are grouping the first two numbers. In the second case, we have grouped the last two numbers. So in the case of addition, the associative law is satisfied. Then let us see what will happen to the multiplication operation. For example, we are multiplying 2 with 3. If we multiply 2 and 3, we will get the result as 6. After getting the result is 6, we are multiplying this 6 with 4. Therefore, the final result is 24. In this case, we are grouping the numbers 2 and 3. Now, we are going to group the numbers 3 and 4. The operation within the bracket, that is within the parenthesis, should be found first. So, if we multiply 3 and 4, we will get 12. After getting the result 12, we are multiplying this 12 with 2. So the final result is 24. So in the first case also the result is 24. In the second case also the result is 24. In both the cases the results are same. It is not changed. Even though we are grouping the first two numbers initially and then the second and third numbers secondly. Therefore, we conclude that in the case of addition operation and multiplication operation, the associative law is also satisfied. Initially, we told that in the case of addition operation and multiplication operation, the commutative law is satisfied. So finally, we are coming to the conclusion that in the case of addition operation and multiplication operation, the commutative law as well as the associative law are satisfied. In this chapter, we are studying 4 topics, that is types of relations, types of functions, composition of functions and invertible function and binary operation. In this sum, we are doing the sum applying the binary operation. What is binary operation? In the case of binary operation, a set is given. In the set, there will be some elements. If we take any 2 elements and perform the given binary operation, the result obtained should also be in the given set. The result cannot be outside the given set. Binary operation. This is the operation of 2 elements of a set A such that the resulting element is also in the set A. We are going to get the answer to the first question, that is finding 2 binary operator with 3 into binary operator with 4 equal to 2 binary operator into 3 binary operator with 4. First of all, we will find the result to the data contained within the bracket, that is within the parenthesis. So in the left side, the parenthesis is put between the first and the second number. In the case of the right side, the parenthesis is put between the second and the third number. On seeing this expression, what we realize that they are asking whether the associative law is satisfied or not. They are not writing that word. The given expression says that whether the associative law is satisfied. Why? What is the associative law? In whatever way we group the elements, the result should not be changed. The result should be the same wherever we put the parenthesis. In the case of left side expression, the parenthesis is put between the first and the second number. In the case of right side expression, the parenthesis is put between the second and the third number. So here the group is changed. First of all, we should find the result to the left side expression. That is 2 binary operator with 3 into binary operator with 4. As I already told, we should find the result for the numbers contained within the bracket, that is parenthesis. So here the parenthesis is between 2 and 3. So we are going to find the result of 2 binary operator 3. 2 binary operator 3 is 1. So that result is written here. Then the result obtained 1 is to be binary operator with 4. If 1 is binary operator with 4, we will get the result as 1. So the result 1 is written here. So we are getting the result for the left side expression 2 binary operator with 3 into binary operator with 4 is equal to 1. Now we are going to get the result for the right side expression, that is 2 binary operator into 3 binary operator with 4. First of all, we are going to get the result for the data contained within the bracket. Here the data contained within the bracket is 3 and 4. So that 3 binary operator 4 is to be found first. When 3 is binary operator with 4, the result is 1. When 2 is binary operator with 1, when 2 is binary operator with 1, we will get 1. So the 1 is written here. So in the case of right side expression also, that is 2 binary operator into 3 binary operator with 4 is also 1. So even though the groups are changed, in whatever way the groups are formed, the result is the same. The result is not changed. Therefore, the associative law is satisfied in the given binary operation. Then coming to the second question is, the binary operation given is commutative or not. If 4 is binary operator with 2, that is 4 binary operator with 2, we will get the result as 2. Then when 2 binary operator with 4, the result in this case also 2. In the place of 4, we have substituted 2. In the place of 2, we have substituted 4. That is we have interchanged the position of the numbers. Even though we have interchanged the position of the numbers, the result is the same. The result is not changed, so that commutative law is satisfied in the given binary operation. We will see one more example. That is, if 3 binary operated with 1, if 3 binary operated with 1, we will get the result as 1. If 1 binary operated with 3, 1 binary operated with 3, we will also get the result as 1. In this case also, if we interchange the position of the numbers, the result obtained is same. That is, the result is not changed. So that in this example also the commutative law is satisfied. Then coming to the third question, that is, compute 2 binary operated with 3, binary operated 4, binary operated with 5. First of all, we are going to find the result for the data contained in the first parenthesis. What is the first parenthesis? 2 binary operated with 3. What is 2 binary operated with 3? 2 binary operated with 3 is the result of 1. Then we are going to find the result for the data given in the second parenthesis. What is the data given in the second parenthesis? 4 binary operated with 5. So the 4 binary operated with 5 is the result of 1. 4 binary operated with 5 is also getting the result of 1. So if we substitute 1 in the place of 2 binary operated with 3 and 1 in the place of 4 binary operated with 5, we will get 1 into 1, 1 into 1 equal to 1. My dear students, in this video we have seen that in the case of addition operation and multiplication operation, the commutative law as well as the associative law is satisfied. In this video we have learned what is associative law and what is commutative law. If this video is most beneficial to you, you can share this video with your friends and classmates. You can also subscribe my channel. My dear students and parents, in this video we are going to learn how to write the multiplication table using the binary operation in the chapter Relations and Functions in the subject Mathematics to the +2 Cbse students. You can see this information on the board. The question is, consider the binary operation on the set 1, 2, 3, 4, 5 defined by A binary operated B equal to minimum of the set A comma B. Write the multiplication table of operation. In the chapter Relations and Functions, we are studying 4 topics. They are types of functions, types of relations, composition of functions and invertible function, lastly binary operation. In this sum, we are going to see the topic binary operation. What are the fundamental operations of mathematics? There are 4 types of fundamental operations in the mathematics. They are addition, subtraction, multiplication and division. In this operation, we are going to find the binary operation. What is binary operation? A set will be given. In the set, there will be some elements. We can take any two elements and we should perform the binary operation as described in the question. After performing the binary operation, we will get a result. That result we obtained should be included in the given set. In this sum, the set is given as 1, 2, 3, 4, 5. Of these 5 elements, we can take any 2 elements. After taking any 2 elements, we should perform the binary operation. The given binary operation in this question is A binary operated B equal to minimum of A, B. We have to write the multiplication table. Multiplication table is also called Cayley table because this table is described by Cayley. Binary operations. It is the operation of 2 elements. It is the operation. It is not the surgical operation. It is the mathematical operation. Here it is the binary operation of 2 elements. 2 elements of a set A such that the resulting element is also in the set A. The resulting element should also in the set A. What are the types of numbers? The types of numbers are natural numbers. It is also called counting numbers. That is, it starts from 1, 1, 2, 3, 4, etc., etc. What are the whole numbers? The whole numbers start from 0. 0, 1, 2, 3, 4. It will go to infinitely. The whole number is denoted by the letter W. The natural numbers are denoted by the letter capital N. Then integers. In the whole number, we cannot take any negative number. Only positive whole number can be taken in the case of the whole number, including 0. The integer includes natural numbers and whole numbers and also negative whole numbers. That is -4, -3, -2, -1, 0, 1, 2, 3, 4, etc., etc. Then rational numbers. What are the rational numbers? The rational numbers are fractional numbers. In these rational numbers, natural numbers, whole numbers, positive integers, negative integers are included. The rational numbers are denoted by the letter capital Q, not by R, not by capital R. Then complex numbers. You know that the complex numbers will be in the form of x plus iy. There will be one real part and one imaginary part. The special character of this complex number is I square equal to -1. In any case, if we square any numbers, we will not get negative. But in the case of the complex number, we will get negative number. That is I square equal to -1. Then real numbers. Real numbers include natural numbers, whole numbers, integers, that is positive integers, and negative integers, rational numbers. The real numbers are denoted by the letter capital R. Capital R. Complex numbers are denoted by the letter capital C. Then coming to the multiplication table, we are going to write in the row that is in the heading row, the numbers given in the set, that is 1, 2, 3, 4 and 5. In the first column also we are writing the elements of the given set, that is 1, 2, 3, 4 and 5. In this corner the binary operation is denoted. As said in the sum, A binary operated B equal to minimum of set A comma B. This is A, this is B. If we are going to binary operator these two numbers, the result should be minimum of these two numbers. What is the minimum of these two numbers? 1 and 1. The minimum of these numbers 1 and 1 is 1. Then we are going to consider the elements 2 and 1. When 2 is binary operated with 1, we will get the minimum number of these two. What is the minimum of 2 and 1? The minimum number of 2 and 1 is 1. Then if we take 3 and 1, what is the minimum of 3 and 1? The minimum of 3 and 1 is 1. Then taking 4 and 1, what is the minimum of 4 and 1? The 1 is the minimum. If we take 5 and 1, what is the minimum of 5 and 1? The minimum of 5 and 1 is 1. In this way we can write all the entries. Then considering 1 and 2, what is the minimum of 1 and 2? 1. Then considering 2 and 2, what is the minimum of 2? That is the same 2. If we take 3 and 2, what is the minimum number? That is 2. If we take 4 and 2, what is the minimum number? 2. If we take 5 and 2, what is the minimum number? 2. If we take 1 and 3, what is the minimum number? 1. If we consider 2 and 3, what is the minimum number? 2. If we take 3 and 3, what is the minimum? 3. If we take 4 and 3, what is the minimum number? 3. Considering 5 and 3, the minimum is 3. Considering 1 and 4, the minimum is 1. Taking 2 and 4, the minimum number of these two is 2. Taking 3 and 4, the minimum of these 3 and 4 is 3. Taking 4 and 4, the minimum of these two numbers is 4. 5, if we take 5 and 4, the minimum number of these two numbers is 4. Taking 1 and 5, the minimum is 1. Taking 2 and 5, the minimum is 2. Taking 3 and 5, the minimum is 3. Considering 4 and 5, the minimum number is 4. Taking 5 and 5, the minimum is 5. In this way, we can easily write the multiplication table of the given set 1, 2, 3, 4, 5. My dear students, if this video is most beneficial to you, you can share this video with your friends and classmates. You can also subscribe my channel. My dear students and parents, in this video we are going to study how to calculate the conductivity and molar conductivity of a solution, that is electrolytic solution. By God's grace, my educational videos are available in YouTube to the 10th Cbse plus 1 Cbse plus 2 Cbse NEET and IIT students in the subjects mathematics, physics, chemistry, zoology and botany in English language. The sum is the resistance of a conductivity cell filled with 0.1 mole per liter potassium chloride, that is KCl solution, is 100 ohms. If the resistance of the same cell when filled with 0.02 mole per liter potassium chloride solution is 520 ohms. Calculate the conductivity and molar conductivity of 0.02 mole per liter potassium chloride solution. The conductivity of 0.1 mole per liter potassium chloride solution is given in the sum. The solution, that is the electrolytic solution given is potassium chloride, that is KCl. This solution, that is electrolytic solution potassium chloride, is given in two concentrations. Now let us see what is the concentration given in the first case and what is the resistance given in the first case and what is the conductivity of the solution given in the first case. That is, in the first case the concentration is 0.1 mole per liter. At this concentration the resistance of the cell is 100 ohms. At this concentration the conductivity, that is K, that is kappa, at this concentration is 1.29 Siemens per meter. So in the case of 0.1 mole per liter concentration of potassium chloride, three data have been given: concentration, resistance and the conductivity. In respect of the second concentration, they have provided only the concentration and the resistance. They did not supply the conductivity of the solution at this concentration. We have to find the conductivity of the solution in this concentration. In the second case, the concentration is given as 0.02 mole per liter. The resistivity of the solution is given as 520 ohms. In respect of the second case, the concentration C is given as 0.02 mole per liter and the resistance at this concentration is provided as 520 ohms. They are asking not only to find the conductivity of the solution at this concentration, that is 0.02 mole per liter, they have also asked to find the molar conductivity of the solution at this concentration, that is 0.02 mole per liter. First of all, we can find the conductivity of the solution at the concentration of 0.02 mole per liter, that is potassium chloride solution. First of all, we have to write the formula for the conductivity, that is K, that is kappa. The formula for the conductivity equal to cell constant, that is G star by resistance capital R. The formula for the conductivity kappa equal to cell constant G star by resistance capital R. We have discussed so many times, from one equation we can find the only one unknown data subject to the condition if we know the values of all other data. In this equation, that is to the conductivity, there are three data. One data in the left side and two data on the right side. And the left side data is conductivity. Resistance at this concentration 0.02 mole per liter is given as 520 ohms. But without knowing the cell constant, that is capital G star, we cannot find the conductivity of the potassium chloride solution at this 0.02 mole per liter concentration. So how can we find the cell constant? That is the next question. We can find the cell constant using the data given in the first case, that is in the 0.1 mole per liter concentration solution. Explanation to get the above formula to conductivity. We know that resistance is directly proportional to the length of the wire taken, and the resistance is inversely proportional to the cross-sectional area of the conductor taken. So resistance directly proportional length of the wire, that is conductor. The resistance is inversely proportional to the cross-sectional area of the wire, that is conductor. If we combine both, we will get resistance is directly proportional to L by A, that is length of the wire by cross-sectional area of the wire, that is conductor. If we change this proportionality relation into equality relation, a proportionality constant will come. That proportionality constant is rho, that is resistance R equal to rho L by A. What is this rho? This rho is the resistivity, that is specific resistance. The IUPAC recommendation is to use the term resistivity over specific resistance, so that we are going to use the term resistivity instead of specific resistance. Both are same. What is the relation between resistivity and conductivity? The conductivity is inverse of the resistivity. So now we can write the equation for resistance as R equal to 1 by K L by A. What is this K? As we have already told, this K is the kappa. It denotes the conductivity. If we change the sides, we will get 1 by K L by A equal to capital R, that is resistance. Therefore, the L by A equal to R into K. So we will get L by A as resistance into conductivity. What is this L by A? This L by A is nothing but cell constant G star. L by A is the cell constant G star. RK is also cell constant, that is G star. Now we have got the formula to find the cell constant. If we want to find the cell constant, we should multiply the resistance with the conductivity. In the first case, they have given the resistance and the conductivity. of 0.1 mole per liter solution. By using that data, we can easily find the cell constant of the given potassium chloride solution. What is the unit of cell constant? The unit of cell constant is per meter. How we get the unit of cell constant as per meter? Let us see. Unit of cell constant L by A is, what is the unit of length? The unit of length is meter. What is the unit of area? The unit of the area is meter square. So m by m square. Thereby we will get 1 by m. 1 by m is the per meter. So the unit of cell constant using L by A is given as per meter. We are going to find the unit using the resistance and the conductivity. Unit of cell constant using resistance and conductivity. What is the formula for the cell constant? Relating resistance and conductivity, the cell constant equal to resistance into conductivity. Capital R into K. What is the unit of resistance? The unit of resistance is ohm. What is the unit of conductivity? The unit of conductivity is mho per meter or Siemens per meter. What is this mho? This mho is the inverse of ohm. That is mho equal to 1 by ohm. So if we write this mho as 1 by ohm, we will get Rk equal to, that is the unit of Rk equal to ohm into 1 by ohm per meter. We can cancel the numerator ohm and the denominator ohm, so the remaining is per meter. So here also we are getting the unit of cell constant as per meter. Now the cell constant G star is calculated using the first case of the solution, that is 0.1 mole per liter concentration solution. The conductivity of that 0.1 mole per liter concentration of the solution is provided as 1.29 Siemens per meter. So the formula for the cell constant G star is written as resistance capital R into conductivity K kappa. So the resistance is substituted as 100 ohms and the conductivity is substituted as 1.29 Siemens per meter. The Siemens per meter is the unit of the conductivity. So if we multiply both, we will get the cell constant, that is capital G star, as 129 per meter. Now the value of cell constant is in our hands. So if we substitute this cell constant and the resistance of the second concentration, that is 0.02 mole per liter concentration, we can find the conductivity as well as molar conductivity of that 0.02 mole per liter concentration solution. So coming to that derivation, coming to the solution of second concentration 0.02 mole per liter of potassium chloride solution. The formula for the cell constant is again written, that is resistance into conductivity. If we interchange the sides, we will get resistance, that is capital R, into conductivity K kappa equal to cell constant capital G star. Thereby we will get the equation for conductivity of 0.02 mole per liter concentration solution. That is cell constant capital G star by resistance capital R. We have determined the cell constant as 129 per meter. In the sum, it is given as the resistance of the 0.02 mole per liter concentration solution is 520 ohms. So if we substitute both data, we can find the conductivity of 0.02 mole per liter solution. So the conductivity K of 0.02 mole per liter concentration solution equal to 0.248 Siemens per meter. What is the unit of conductivity? The unit of conductivity is Siemens per meter. So it is also written here. Now we have found the conductivity of the second concentration, that is 0.02 mole per liter concentration solution. So we can find the molar conductivity from this information. What is the formula for molar conductivity? Finding molar conductivity, lambda m of second concentration 0.02 mole per liter solution of potassium chloride. The formula for the molar conductivity, lambda m equal to conductivity K kappa by concentration C. So we have found the conductivity as 0.248 Siemens per meter. So we can substitute the conductivity as 0.248 Siemens per meter. The second concentration of the solution is provided as 0.02 mole per liter. So that data can also be substituted. If we substitute both this data, that is conductivity and the concentration, we can find the molar conductivity K of 0.02 mole per liter concentration solution. On seeing this molar conductivity, that is 0.248 Siemens per meter by 0.02 mole per liter, what we understand? We can understand that in the numerator the unit is Siemens per meter. In the case of the denominator, the unit is mole per liter. So this liter should also be converted into meter, that is meter cube. Why it should be converted into the meter cube? So that we will get the meter in the numerator as well as in the denominator. The unit will be the same. For that purpose, we are going to convert the unit of mole per liter into mole per meter cube. What is the relation between liter and the meter cube? 1 meter cube contains 1000 liters. In 1 meter cube, there are 1000 liters. If we multiply 0.02 mole per liter with 1000, we will get 20 mole per meter cube. Then again, we are writing the formula for molar conductivity, lambda m. That is 0.248 Siemens per meter by 20 mole per meter cube. Now we have converted the mole per liter into the mole per meter cube. So if we remove the decimal, we should multiply this 0.248 into 1000. We should also divide by 1000, so that the value cannot be changed. So if we multiple 0.248 with 1000, we will get the whole number, that is 248. The denominator can be written as 2 into 10 into 1000. Therefore 10 into 1000 equal to 10,000. 10,000 is nothing but 10 to the power of 4. If we simplify 248 and 2, we will get 124. 124 by 10 to the power of 4. If we bring this denominator 10 to the power of 4 to the numerator, it will become as 10 to the power of minus 4. Hence we are getting the value of molar conductivity lambda m of the second concentration solution, that is 0.02 mole per liter concentration solution, as 124 into 10 to the power of minus 4 Siemens meter square per mole. Why we are writing the unit to the molar conductivity as Siemens meter square per mole? Let us see that information. Why the unit of molar conductivity lambda m is Siemens meter square per mole? What is the formula for molar conductivity? The formula to the molar conductivity lambda m equal to conductivity K kappa by concentration C. What is the unit of conductivity? The unit of conductivity is Siemens per meter. What is the unit of concentration? The unit of concentration is mole per meter cube, because we have converted the unit mole per liter into mole per meter cube. Therefore, if we bring m to the power minus 3 to the numerator, it will become as m to the power 3. If we bring mole to the power 1 to the numerator, it will become as mole to the power minus 1. If the bases are same, we can add the power in the case of multiplication. Here there is multiplication relation. The base is same, that is m. If we add minus 1 and 3, we will get square. Thereby we will get the unit of molar conductivity lambda m equal to Siemens meter square per mole. My dear students, in this video we have studied many formulae, that is how to find the cell constant, how to find the conductivity of the solution, how to find the molar conductivity of the solution, how can convert the mole per liter into mole per meter cube, what are the units of resistance, conductance, resistivity, conductivity, molar conductivity, and so on. Since our elders have formulated these formulae, that is for the cell constant, for the conductivity, for the molar conductivity, we can easily calculate the molar conductivity of the solution and the conductivity of the solution. If our elders do not construct these formulae, how can we find the conductivity of the solution and molar conductivity of the solution? Definitely we cannot find it. If the students want to know all information in this chapter, I appeal to the students to see all my videos. If this video is most beneficial to you, you can share this video with your friends and classmates. You can also subscribe my channel. My dear students and parents, in this video we are going to learn how to find the values of x, y, z, a, b and c if two matrices are equal. In the chapter matrices, in the subject mathematics to the +2 Cbse students. By God's grace, my educational videos are available in YouTube to 10th Cbse, +1 Cbse, +2 Cbse, NEET and IIT students in the subjects mathematics, physics, chemistry, zoology and botany in English language. The question is, if the matrix x plus 3, z plus 4, 2y minus 7, minus 6, a minus 1, 0, b minus 3, minus 21, 0 is equal to the matrix 0, 6, 3y minus 2, minus 6, minus 3, 2c plus 2, 2b plus 4, minus 21, 0. Find the values of x, y, z, a, b, c. In the sum, two matrices have been given. The two matrices are said to be equal. The two matrices are said to be equal. On saying these two matrices are equal, they are asking to find the values of some data. We know that the matrices chapter is one of the easiest chapter in the +2 mathematics to get the full marks. In this matrices chapter, we are going to see 10 topics: order of the matrix, equality of the matrices, type of the matrices, addition of the matrices, difference of the matrices, multiplication of the matrices, multiplication of a matrix by a scalar, transpose of the matrix, of a matrix by elementary operations, symmetry matrix and skew symmetric matrix, and so on. This information have been given on the board. If two matrices are said to be equal, two conditions should be satisfied. First condition is the order of the both matrices must be equal. The second condition is each element of the first matrix should be equal to the corresponding elements of the second matrix. That is Aij equal to Bij. What is I? It denotes the number of rows. What is J? It denotes the number of columns. Two conditions to say the given two matrices are equal. One, the order of the two matrices must be equal. Each element of the first matrix must be equal to the corresponding element of second matrix. That is Aij equal to Bij for all Ij. The first matrix is of the order 3 by 3. The second matrix is also of the order of 3 by 3. Why? Because in the first matrix there are 3 rows. This is first row, this is second row, this is third row. There are 3 columns. This is the first column, this is the second column, this is the third column. So this matrix is of the order of 3 by 3. In this case also, in this matrix also, there are 3 rows. 1, this is first row, this is the second row, this is the third row. This is the first column, this is the second column, this is the third column. So it is also of the order of 3 by 3. So the first condition is satisfied. Both the matrices are of the order of 3 by 3. Then we are going to equate the each element of the first matrix with the corresponding element of the second matrix. What is the first row, first column element? That is A11 x plus 3. What is the first row, first element? That is the corresponding element of the second matrix, that is B11, that is 0. So we can equate x plus 3 and 0. That is x plus 3 equal to 0. Then what is x? The x is 0 minus 3. That is the x equal to minus 3. Then we are equating the first row, second element of the first matrix with the first row, second element of the second matrix. What is the first row, second element of the first matrix? Z plus 4. What is the first row, second element of the second matrix? That is B1 to 6. If we equate Z plus 4 to 6, we will get Z plus 4 equal to 6. Then Z equal to 6 minus 4. That is Z equal to 2. So we have found the values of x and z. Now we are going to find the value of y. Where the y is placed? The y is placed in the first row, third column. That is in A13 2y minus 7. What is the element present in the corresponding first row, third column of the second matrix? That is in B13 3y minus 2. So if we equate both, we will get the value of y. 2y minus 7 equal to 3y minus 2. If we bring 3y to the left side, it will become as minus 3y. If we bring minus 7 to the right side, it will become as plus 7. So 2y minus 3y equal to minus y equal to 5. Then y equal to minus 5. Then we are going to equate A22 with B22. That is A minus 1 equal to minus 3. Therefore, A equal to minus 3 plus 1. That is A equal to minus 2. Then we are going to equate A31 with B31. That is B minus 3 equal to 2B plus 4. If we bring 2B to the left side, it will become as minus 2B. If we bring minus 3 to the right side, it will become as plus 3. So we will get minus B equal to 7. Therefore B equal to minus 7. And we are going to equate A23 with B23 because these are corresponding elements in order to find the value of C. So 0 equal to 2C. If we interchange the sides, 2C plus 2 equal to 0. Therefore 2C equal to minus 2, C equal to minus 2 by 2, that is C equal to minus 1. In this way, if two matrices are given and if it is said that those two matrices are equal, we can find the value of any data. My dear students, if this video is most beneficial to you, you can share this video with your friends and classmates. You can also subscribe my channel. My dear students and parents, in this video we are going to suggest a way to determine the limiting molar conductivity value of water. In the chapter electrochemistry, in the subject chemistry to the +2 Cbse students, you can see this fact on the board. By God's grace, my educational videos are available to 10th Cbse, +1 Cbse, +2 Cbse, NEET and IIT students in the subjects mathematics, physics, chemistry, zoology and botany in English language. Here the question is, suggest a way to determine the limiting molar conductivity value of water. In this question, they are not asking to find the limiting molar conductivity value of water. They are simply asking to suggest a way to determine the limiting molar conductivity of water. We know that water is a weak electrolyte. What is electrolyte? Electrolyte is a substance. When this substance is dissolved in water, it breaks into, that is, it dissociates into its constituent ions, that is cations and anions. What is strong electrolyte? Strong electrolyte is a solution or solute. This solution or solute completely or almost completely ionizes or dissociates into its constituent cations and anions. What is weak electrolyte? Weak electrolyte is also a solution or solute. In this case, the solution or solute does not completely ionize, does not completely dissociate into its constituent ions, that is cations and anions. That is, in the case of weak electrolyte, the solution or solute partially dissociates, partially ionizes into its constituent ions. We have to find the limiting molar conductivity of water applying the Cole-Rauch law of independent migration of ions. Why should we select the Cole-Rauch law of independent migration of ions in order to determine the limiting molar conductivity of a weak electrolyte? We know that weak electrolytes such as acetic acid have lower degree of dissociation at higher concentration. Note the word, at the higher concentration. When we add more and more water in the weak electrolyte, that is at infinite dilution, the concentration of the electrolytic solution becomes zero. When the concentration becomes zero, the electrolyte dissociates completely. That is, the degree of dissociation equal to 1. Note the point. We already told that the weak electrolytes have the lower degree of dissociation at higher concentration. Here we have made the concentration to 0. So at this lower concentration, the electrolyte dissociates completely. In this lower concentration, the conductivity of the solution becomes very low. So, the conductivity of the solution cannot be measured accurately in this low concentration. For that reason, we are following the Cole-Rauch law of independent migration of ions. In the question, no other information is given other than the statement that suggests a way to determine the limiting molar conductivity of the water. So, we have to think, how can we get the water? We are well aware that when the acid combines with the base, we will get salt and water. So, let us take an acid, that is hydrochloric acid, HCl. HCl is a gas. When it is dissolved in water, it becomes the acid, that is hydrochloric acid. It is going to combine with the base sodium hydroxide. So the acid combines with the base, that is sodium hydroxide, to form the salt. Which salt? The sodium chloride salt and water. See the equation. HCl is the acid, sodium hydroxide is base, sodium chloride is salt, H2O is water. So from this equation we can get the equation for the water, that is H2O. Then what is the equation for water? If we bring sodium chloride from left side to right side, it will become as minus sodium chloride, that is NaCl. What is the Kohlrausch law of independent migration of ions? The law states that the limiting molar conductivity, that is lambda m naught of an electrolyte, can be represented as the sum of the limiting molar conductivity of the cations and the limiting molar conductivity of the anions of that electrolyte. It means that if we add the limiting molar conductivity, that is lambda m naught of the cations, and the limiting molar conductivity, that is lambda m naught of the anions, we will get the limiting molar conductivity of the electrolyte. So we can write this equation applying the Kohlrausch law of independent migration of ions, that is limiting molar conductivity of water equal to limiting molar conductivity of HCl plus limiting molar conductivity of sodium hydroxide minus the limiting molar conductivity of sodium chloride. This is the way to determine the limiting molar conductivity value of water. It is not asked to determine the limiting molar conductivity value of water, but we can easily find the limiting molar conductivity of the water applying the Kohlrausch law of independent migration of ions. How can we determine? That is limiting molar conductivity of H2O equal to the limiting molar conductivity of HCl can be written as limiting molar conductivity of H plus plus limiting molar conductivity of Cl minus. Similarly, the limiting molar conductivity of sodium hydroxide, that is base, can be written as limiting molar conductivity of Na plus plus limiting molar conductivity of OH minus. Likewise, we can also write the limiting molar conductivity of sodium chloride as limiting molar conductivity of Na plus plus limiting molar conductivity of Cl minus. The Kohlrausch examined limiting molar conductivity for a number of strong electrolytes. We can get the information for the limiting molar conductivity of the cations and the anions from the table given. If you see the table, you can understand that what are the limiting molar conductivity value of cations and the anions. My dear students, if this video is most beneficial to you, you can share this video with your friends and classmates. You can also subscribe my channel. If you want to get all information contained in this chapter, I appeal to the students to see all my videos. My dear students and parents, in this video we are going to study how to differentiate a given function. In the chapter Continuity and Differentiability, in the subject Mathematics, to the +2 Cbse and IIT students. It is also useful to +1 Cbse students. By God's grace, my educational videos are available in YouTube to 10th Cbse, +1 Cbse, +2 Cbse, NEET and IIT students in the subjects Mathematics, Physics, Chemistry, Zoology and Botany in English language. You can see this information on the board. Let us go to the sum. Differentiate the given function with respect to x. 3x square minus 9x plus 5 the whole to the power 9. Derivatives of some standard functions and the derivatives of some inverse trigonometric functions. We know that on differentiating x to the power n, we will get n x to the power n minus 1. On differentiating c x to the power n, we will get cn x to the power n minus 1. On differentiating the constant, we will get 0. On differentiating sin x, we will get cos x. On differentiating cos x, we will get minus sin x. On differentiating tan x, we will get secant square x. On differentiating cot x, we will get minus cosecant square x. On differentiating cosecant x, we will get minus cosecant x into cot x. On differentiating secant x, we will get secant x tan x. On differentiating log x, we will get 1 by x. On differentiating e to the power x, we will get the same e to the power x. As per the product rule, on differentiation, we will get u dv plus v du. As per quotient rule, on differentiation, we will get v du minus u dv by v square. Now we are going to see about some inverse trigonometric functions. If we differentiate sin inverse x, we will get 1 by root of 1 minus x square. On differentiating cos inverse x, we will get minus 1 by root of 1 minus x square. On differentiating tan inverse x, we will get 1 by 1 plus x square. On differentiating cot inverse x, we will get minus 1 by 1 plus x square. On differentiating cosecant inverse x, we will get minus 1 by x into root of x square minus 1. On differentiating secant inverse x, we will get 1 by x into root of x square minus 1. You can see all this information on the board. On seeing this information, we understand that if the first letter of the function comes as c, we are getting the minus sign on differentiation. The first letter of this function is c, so that we are getting minus sign on differentiation. The first letter of this function is also c, so that the minus sign has come. In this function also the first letter is c, so that we are getting minus sign. Here also we can see that fact. The first letter of cos inverse x is C, so that we are getting the minus sign. In the case of cot inverse x function, the first letter is C, so that the minus sign has come. In the case of cosecant inverse x, the first letter is C. Here also we are getting the minus sign. Therefore, it is concluded that if the first letter of the function is C, on differentiation we will get the negative sign. Before proceeding differentiation, we should know some details. The first detail is we should see how many terms are there in the given function. For example, if we take this expression, that is function, we confirm that this is the first term. That is, first term is 3x square. The second term is minus 9x. The third term is 5. What is term? Theta is combined, or we can say separated by plus or minus. Each data is called as a term. We know that each term should be differentiated separately, so that we have to decide how many terms are there in the given function. Then the next information we have to observe is what is the coefficient, what is the variable, and what is the constant in each term. If we consider this expression, that is function, we confirm that the variable is x, the constant is 5, and the coefficient is 3 and minus 9. What is coefficient? Coefficient is a number coming along with the variable. What is the constant? It is also a number, but it comes alone. It is a pure constant, just like pure ghee. The constant will not come along with the variable. Many times some students get confusion whether we have to differentiate as per the chain rule or as per the product rule. Suppose if the given function is in this format, that is log of sin x, we should differentiate as per chain rule. The reason is the variable has come only once. We should note this point. If the variable comes only once with two or more functions, we should differentiate as per the chain rule. Here the variable is x. This variable x has come only once, but it has come with two functions. One is logarithmic function, another is sine trigonometric function. So we should differentiate as per chain rule. Note the difference between this expression and this expression. In this expression also the variable is x, but here the variable has not come only once, it has come two times. In addition to the fact of coming two times, they have come as a product, so that it has to be differentiated as per the product rule. First, the variable x has come with a logarithmic function, then the same variable x has come with the sine trigonometric function. So if the function has come in such manner, we should differentiate as per the product rule. Note the difference between the chain rule of differentiation and the product rule of differentiation. In the chain rule, the variable x will come only once, but with two or more functions. In the case of product rule, the variable comes two times. First time with one function, second time with another function. So this is the difference between the chain rule and the product rule. Square minus 9x plus 5 the whole to the power 9. The next information we have to see is what is the coefficient in each term, what is the constant. In the first term the coefficient is 3. In the second term the coefficient is minus 9. So that I have written the coefficients equal to 3 and minus 9. Then we have to see what is the variable. The variable is x. Here the variable x has come with power 2. Here the variable x come with power 1. Then we have to see what is the constant. This 5 is the constant. Hence, in the given function, there is constant, there is variable, there are also coefficients. We know that first of all, we should differentiate the power as per the rule of differentiating x to the power n equal to n into x to the power n minus 1. So first we are going to differentiate the power. Differentiating as per rule of differentiation of x to the power n equal to n into x to the power n minus 1. So on differentiating the left side, what we will get? We are going to differentiate the variable y, so that we will get dy. We are going to differentiate the variable y with respect to which variable? We are going to differentiate the variable y with respect to variable x, so that we should put dx in the denominator. Thereby we will get dy by dx in the left side. Coming to the right side, the power is 9, that is the exponent is 9. As per this rule, this power should become as the coefficient of this expression. Therefore, we have to write this power in front of this expression. Then after writing the power as coefficient of the given expression, we should reduce 1 from the power. That is n minus 1. What is n? N is 9. We have to reduce 1, so that we will get 9 minus 1. As I already stated that our duty is not over after differentiating the power, that is exponent. Then we have to differentiate the function, that is we have to differentiate the given expression. So we are writing differentiation of 3x square minus 9x plus 5. We should combine this as a product. Don't put plus or minus between these two expressions. Sometimes the students are writing plus or minus between these two expressions. Don't write plus or minus, it should be multiplied. It is as per the chain rule. That is, it is as per the function of function. That is, it is as per the composite function. Dy by dx has come as 9 into 3x square minus 9x plus 5 the whole power 8. 9 minus 1 equal to 8 into, then we are going to differentiate this first term. Each term should be differentiated separately, don't forget. So what is the first term? The first term is 3x square. So here also the power should come as the coefficient and after writing the power as coefficient, the power should be reduced by 1. So if we reduce the power by 1, we will get in the power as 2 minus 1. Then coming to the second term. The second term is minus 9x. So what is the power of this variable? The power of this variable x is 1. That 1 should come as the coefficient. So I am writing 1 before this 9x. Then the power should be reduced by 1. Thereby I have written as 1 minus 1. Then coming to the constant. We know that on differentiating the constant, we will get 0. Initially, we have seen the derivatives of some standard function. In that, we have mentioned that on differentiating the constant, we will get 0. So, I am writing 0 on differentiating this constant 5. Now, the dy by dx is arrived as dy by dx equal to 9 into 3x square minus 9x plus 5 whole to the power 8, 2 into 3, 6, x to the power 2 minus 1 equal to x, minus 1 into 9, 9, x to the power 1 minus 1 equal to x to the power 0. We know that any data to the power 0 is equal to 1. So if we write x to the power 0 as 1, we will get dy by dx as 9 into 3x square minus 9x plus 5 the whole power 8 into 6x minus 9 into 1. I am substituting 1 in the place of x to the power 0. Then the dy by dx becomes as 9 into 3x square minus 9x plus 5 the whole power 8 into 6x minus 9. Now we are going to take the common factor outside. In this factor 6x minus 9. What is the common factor? In this expression the common factor is 3. So that we are going to take 3 outside this 6x minus 9. If we take the common factor 3, we will get dy by dx equal to 9 into 3x square minus 9x plus 5 the whole power 8, 3 into 2x minus 3. If we multiply 9 into 3, we will get 27. So now we will get the equation as dy by dx equal to 27 into 3x square minus 9x plus 5 the whole power 8 into 2x minus 3. If we interchange the position of the factors, we will get dy by dx as 27 into 2x minus 3 into 3x square minus 9x plus 5 the whole power 8. In this video, you have learned that how to differentiate each term separately. What is the coefficient? What is the constant? What is the variable? How to we differentiate x to the power n? What we will get on differentiating the constant? These are the knowledge we have gained in this video. My dear students, if this video is really beneficial to you, you can share this video with your friends, classmates and relatives. You can also subscribe my channel. My dear students and parents, in this video, we are going to learn about the identity element, inverse element, identity matrix in the chapter matrices in the subject mathematics to the +2 Cbse and IIT students. It is also useful to +1 Cbse students. By God's grace, My educational videos are available in YouTube to 10th Cbse, plus 1 Cbse, plus 2 Cbse, NEET and IIT students in the subjects mathematics, physics, chemistry, zoology and botany in English language. There are two types of identity. One is additive identity. The second is multiplicative identity. The identity is denoted by the symbol small e. Two types of identity. One is additive identity, another is multiplicative identity. What is additive identity? Suppose we are taking a number. The number taken may be natural number, whole number, positive integer, negative integer, rational number, real number, and so on. If you are taking a number, after taking that number, you are adding another number. After adding another number with the number taken, we should get the number initially taken. What will be that another number? That another number is nothing but 0. That is why 0 is called additive identity element. That is, we are taking a number. The 7 is taken. We are adding 0 with this number 7. What the number we will get? We will get the same number taken by us. Therefore, this 0 is the additive identity. You can take any number. 1 crore, 1 lakhs or 10 lakhs. If you add 0 with that number, you will get the number taken by us. The number taken is 1000. We are adding 0. We are getting the answer as 1000. That is the number taken by us. The number taken is denoted by small a. The additive identity is denoted by E. That is A plus E equal to A. We can also interchange the position of the number as per the commutative property. First of all, we can take the additive identity. After taking the additive identity, we can add any number. In that case also, we will get the number taken by us. We have seen about the additive identity. Now we are going to see what is multiplicative identity. If we multiply any number by 0, we will get the same number taken by us. No, we will get the answer as 0. So 0 is not the multiplicative identity. Then what will be the multiplicative identity? We should take a number. After taking the number, in this case, we should perform the multiplicative operation. If we multiply the number taken by us with another number, we should get the number taken by us. What will be that another number? That another number in this place is nothing but 1. Take any number. After taking that number, you multiply that number by 1. You will get the number taken by us. That's all. That is, here, for instance, the 9 is taken. The 9 is multiplied by 1. If it is multiplied with 1, we will get the number that is 9 taken by us. Here we are taking 1 lakh. That 1 lakh is multiplied by 1. We will get the 1 lakh taken by us. So this 1 is the multiplicative identity. This is expressed as small a into E equal to E. Here what is E? The E is multiplicative identity. The multiplicative identity is 1. We can also change the position of the number as per the commutative property. If E is multiplied with A, in that case also we will get A. That is the number taken by us. From these examples, we conclude that 0 is the additive identity, 1 is the multiplicative identity. Hence there are two types of identity. Then coming to the inverse. In the case of inverse also, there are two types. One is additive inverse, another is multiplicative inverse. Here also we are taking a number, any number. After taking the number, if we add with its inverse, we will get the identity. That is additive identity. If we take the additive inverse, we will get the additive identity. For example, we are taking a number as 23. What is the additive inverse of 23? You don't write the inverse of 23 as 1 by 23, because 1 by 23 is the multiplicative inverse of 23. Here we are talking about the additive inverse of 23. What is the additive inverse of 23? The additive inverse of 23 is minus 23. So 23 minus 23 equal to 0. What is this 0? This 0 is the additive identity. So if we add a number with its additive inverse, we will get the additive identity. We are taking another number, that is 100. The additive inverse is minus 100. We will get the number as 0. That is, we will get the additive identity. Sir, can I take minus 100 first and plus 100 second? Yes, you can take, because the inverse of, that is the additive inverse of minus 100 is plus 100. So minus 100 plus 100 equal to 0. 0 is the additive identity. This is expressed as A minus A. What is this minus A? This minus A is the additive inverse of this A. We will get the identity. Then coming to the multiplicative inverse. In this case also, we are taking a number. In this place, we are going to perform the multiplication operation, so that we should take the multiplicative inverse of the number taken. So if we multiply any number by its multiplicative inverse, we will get 1. What is that 1? That 1 is the multiplicative identity. We are taking the number 23. The multiplicative inverse of 23 is 1 by 23. In that case, we have taken the additive inverse. In this place, we are taking the multiplicative inverse, so that we are taking 1 by 23. What is 23 into 1 by 23? We will get 1. What is 1 in this case? This 1 is the multiplicative identity. So if we multiply any number with its multiplicative inverse, we will get the multiplicative identity, that is 1. It is expressed as A into A inverse equal to E. This E is the multiplicative identity. This law holds good in the case of identity matrix also. In order to confirm the identity matrix, 4 conditions should be satisfied. The first condition is it should be a square matrix. That is, the number of rows should be equal to the number of columns. The second condition is there should be elements only in the diagonal. The non-diagonal number should be 0. This is the second condition. The third condition is the elements in the diagonal should be the same. The fourth condition is the elements in the diagonal should be 1. Let us see whether these 4 conditions have been satisfied in the case of identity matrix. Identity matrix. The matrix A. There are 3 rows and 3 columns, so that the number of rows is equal to the number of columns. So it is a square matrix. In the case of square matrix, the number of rows should be equal to the number of columns. The first condition is satisfied. The second condition is there will be elements only in the diagonal. The non-diagonal elements should be 0. In the case of non-diagonal elements, there are 0. Thereby, the second condition is satisfied. The third condition is the diagonal elements will be same. Here the diagonal elements are same, so that the third condition is also satisfied. The fourth condition is diagonal elements should be 1. Here the diagonal elements are 1. Hence the 4 conditions are satisfied. Therefore we can call this matrix as identity matrix. We are taking any matrix and we are multiplying that matrix with the identity matrix, then we will get the matrix taken by us. We are taking any matrix, we are multiplying that matrix with the inverse of that matrix. If we multiply the matrix taken with its inverse, we will get the identity matrix. This law holds good in the case of the operation of matrix. This law holds good in the case of addition of matrices. In that case, we should take the 0 matrix, that is null matrix, in the case of addition of matrices. Then only we will get the matrix taken by us. If you want to know all information in this chapter, I appeal to the students to see all my videos. If this video is really beneficial to you, you can share this video with your friends, classmates and relatives, and you can also subscribe my channel. My dear students and parents, in this video we are going to learn what are the types of matrices in the chapter matrices in the subject mathematics to the +2 Cbse students and IIT students. By God's grace, my educational videos are available in YouTube to 10th Cbse, +1 Cbse, +2 Cbse, NEET and IIT students in the subjects mathematics, physics, chemistry, zoology and botany in English language. What are the types of matrices? There are 7 types of matrices. The first type is column matrix. What is column matrix? If there is only one column in a matrix, that matrix is called column matrix. Matrix A, there is only one column, but there are 4 rows. So we are considering only the column. In the case of column matrix, what is the order of this column matrix? The order of this column matrix is 4 by 1. That is 4 rows and 1 column. Number of rows should be written first, followed by the number of columns. Then row matrix. What is row matrix? If there is only one row in a matrix, that matrix is called row matrix. The matrix B equal to only one row, but there is 4 columns. We are considering only the rows. So that if there is only one row, it is the row matrix. The order of this row matrix is 1 by 4. 1 row, 4 columns. Then coming to the square matrix. If the number of rows are equal to the number of columns, that matrix is called square matrix. That is matrix A. First row, second row, third row. There are 3 rows. First column, second column, third column. There are 3 columns. So in this matrix there are 3 rows and 3 columns. The number of rows is equal to the number of columns, so that this matrix is called as square matrix. Sir, can I take 2 by 2 matrix, that is 2 rows and 2 columns matrix? Yes, you can take. You can take 2 by 2 matrix, 1 by 1 matrix, or 4 by 4 matrix, and so on. But in any case, you should not take 2 by 4 matrix, 3 by 2 matrix. You cannot take. The reason is the number of rows should be equal to the number of columns. In the case of square matrix, the elements in any row or in any column may be any element. There is no precondition. In the case of diagonal matrix, the 2 conditions should be satisfied. One is, it should be the square matrix. That is, here also the number of rows should be equal to the number of columns. That is the first condition. The second condition is, there should be elements in the diagonal only. The elements other than diagonal should be 0. That is, the non-diagonal element should be 0. Here there are 3 rows and 3 columns. That is, the number of rows is equal to the number of columns. The first condition is satisfied. The second condition, there should be elements only in the diagonal. The non-diagonal elements should be 0. These are the non-diagonal elements. These are 0. That is why this matrix is called as diagonal matrix. Then coming to the scalar matrix. In the case of scalar matrix, 3 conditions should be satisfied. The first condition is, it should also be the square matrix. That is, the number of rows should be equal to the number of columns. Second condition is, there should be elements only in the diagonal. The non-diagonal elements should be 0. The third condition is, the diagonal elements should be same. So these are the 3 conditions for the scalar matrix. That is the first condition. Number of rows should be equal to the number of columns. 3 rows, 3 columns. So the first condition is satisfied. There should be elements only in the diagonal. There is elements only in the diagonal. The non-diagonal elements should be 0. Here the non-diagonal elements are 0. So the second condition is also satisfied. The third condition is, the diagonal elements should be the same. In the case of diagonal matrix, the diagonal elements need not be same. The elements are 1, 4, 7. Here the diagonal elements are same. So this is the third condition. In order to say the scalar matrix. In the case of identity matrix, 4 conditions should be satisfied. The first condition is it should be the square matrix. That is, the number of rows should be equal to the number of columns. The second condition is there should be elements only in the diagonal. The third condition is the diagonal elements should be same. The fourth condition is the diagonal elements should be 1. So these are the 4 conditions identity matrix. First condition, number of rows should be equal to the number of columns. There are 3 rows and 3 columns. So the first condition is satisfied. The second condition is there should be elements only in the diagonal. There are elements only in the diagonal. All non-diagonal elements are 0. So the second condition is also satisfied. The third condition is the diagonal elements should be same. The diagonal elements are same. The fourth condition is the diagonal elements should be 1. So in this case also the diagonal elements is 1. So that the 4 conditions are satisfied. The identity matrix is denoted by the letter capital I. You can take 2 by 2 matrix or 1 by 1 matrix. Number of rows should be equal to the number of columns in order to satisfy the square matrix, diagonal matrix, scalar matrix and identity matrix. If all the elements of the matrix are 0, that matrix is called as 0 matrix. It is also called a null matrix. That is 0 matrix A. There are 3 rows and 3 columns. All the elements are 0. By God's grace, my educational videos are available in YouTube to 10th Cbse, plus 1 Cbse, plus 2 Cbse, NEET and IIT students in the subjects mathematics, physics, chemistry, zoology and botany in English language. I want to say some formulae we have seen in this chapter, current electricity to the current. What are the formulae we have seen in this chapter? The first formula for the current is Q by T. That is current equal to charge by time. It is the rate of charge flowing in a conductor. That is the charge flowing per second is called as current. So that we are dividing the charge by time. Then this is the steady current. That is capital I. The current is not always steady. It will change when the time is changed. So that the instantaneous value of the current, that is small I equal to dq by dt. That is change in charge by change in time. Then we are going to see another formula for current relating potential difference and the resistance. We know that the current equal to potential difference by resistance. That is I equal to V by R, capital V by capital R. Then the formula for the current equal to current density into area. What is current density? The current flowing per unit area is denoted as current density. So per unit area the current flowing is J. Therefore if we multiply by total area we will get the current. Then we are going to see the formula for current relating drift velocity and the total number of electrons. That is current I equal to NAEVD. Current I equal to NAEVD. What is this N? Number of electrons per unit volume. What is this capital A? The cross-sectional area of the conductor. What is this E? The charge of an electron. What is VD? VD is the drift velocity of the electrons. So current equal to number of electrons per unit volume into area into charge of an electron into drift velocity. Then the formula for the current relating power, that is electric power, and potential difference is I equal to P by V, that is electric power by potential difference. Current equal to power by potential difference, I equal to P by V. Then the formula for the current relating heat energy, potential difference and time is I equal to H by Vt, that is I equal to H by Vt. This H is the heat energy, or we can say as electric energy, by potential difference, that is capital V into time. Hence these are the some formulae for the current we have seen in the chapter current electricity. If this video is really beneficial to you, you can share with your friends, relatives and classmates. You can also subscribe my channel. If you want to know all knowledge in this chapter, I appeal to the students to see all my videos. My dear students and parents, in this video we are going to learn how to derive the formula for the current I equal to NAEVD in the chapter current electricity in the subject physics to the +2 Cbse, IIT and NEET students. You can see this information on the board. By God's grace, my educational videos are available in YouTube to 10th Cbse, +1 Cbse, +2 Cbse, NEET and IIT students in the subjects mathematics, physics, chemistry, zoology and botany in English language. Before going to derive the formula for the current I equal to NAEVD, that is, we are going to derive the formula for the current relating drift velocity and the number of electrons, that is total number of electrons in a conductor. We can also say the formula to the current relating drift velocity and charge. Before going to the derivation, I want to say some formulae we have seen in this chapter current electricity to the current. What are the formulae we have seen in this chapter? The first formula for the current is Q by T, that is current equal to charge by time. It is the rate of charge flowing in a conductor, that is the charge flowing per second is called as current, so that we are dividing the charge by time. Then this is the steady current, that is capital I. The current is not always steady. It will change when the time is changed, so that the instantaneous value of the current, that is small I equal to dq by dt, that is change in charge by change in time. Then we are going to see another formula for current relating potential difference and the resistance. we know that the current equal to potential difference by resistance, that is I equal to V by R, capital V by capital R. Then the formula for the current equal to current density into area. What is current density? The current flowing per unit area is denoted as current density. So per unit area the current flowing is J. Therefore if we multiply by total area we will get the current. Then we are going to see the formula for current relating drift velocity and the total number of electrons. That is current I equal to NAEVD. Current I equal to NAEVD. What is this N? Number of electrons per unit volume. What is this capital A? The cross-sectional area of the conductor. What is this E? The charge of an electron. What is VD? VD is the drift velocity of the electrons. So current equal to number of electrons per unit volume into area into charge of an electron into drift velocity. Then the formula for the current relating power, that is electric power, and potential difference is I equal to P by V, that is electric power by potential difference. Current equal to power by potential difference, I equal to P by V. Then the formula for the current relating heat energy, potential difference and time is I equal to H by Vt, that is I equal to H by Vt. This H is the heat energy, or we can say as electric energy, by potential difference, that is capital V into time. Hence these are the some formulae for the current we have seen in the chapter current electricity. First of all, we are taking the formula for the current, that is steady current equal to Q by T. The first formula is taken. From this first formula we are going to get the formula for the current I equal to NAEVD. On seeing this equation I equal to Q by T, we understand that there are three data. We have to find the formula for the current capital I. So if we do not know the total charge Q and the time T, we cannot derive the formula for the current I. First of all, we are going to find the total charge contained in the conductor. How can we find the total charge contained in the conductor? If we know the total number of electrons, we can find the total charge. How can we find the total number of electrons? If we know the number of electrons per unit volume and the total volume of the conductor, we can find the total number of electrons. After finding the total number of electrons, we can find the total charge. After finding the total charge and the time, we can get the formula for the current. Let us see how we are going to get the formula for current as NAEVD. Let N be the number of electrons per unit volume and let capital V be the volume of the conductor. Then what will be the total number of electrons in the conductor taken? This N is the number of electrons per unit volume. We are also having the total volume, that is V. Therefore, we can write if the volume is 1 unit, the number of electrons is small n. But here the volume is not 1 unit. The volume is considered as capital V. So that we can write if the volume is 1 unit, number of electrons is n. Therefore, if the volume is capital V, so if we remove the words, we will get NV. that is the total number of electrons, as NV. We know that volume equal to area into height. Here the height is the length of the wire taken. So that we are writing the volume V as capital AL. L is the cross-sectional area, L is the length of the wire, that is the length of the conductor. So we know that volume equal to area into height, that is capital V equal to capital A into L. Therefore, if we substitute AL in the place of V in the equation NV, we will get the total number of electrons as NaL. So now we have calculated the total number of electrons contained in the conductor taken. We don't need the total number of electrons. We need the total charge, that is Q, and also the time. From this total number of electrons, we have to calculate the total charge Q. How can we calculate the total charge Q, that is small q? We know that the charge of an electron is denoted by the letter small e. The value of the charge of the electron is also known to us, that is 1.602 into 10 to the power of minus 19 coulomb. But here we are taking the charge of an electron as small e. If there is only one electron, the charge is small e. Here there is no one electron. There are NaL number of electrons in the conductor. So if the number of electron is 1, the charge is small e. Therefore, if the number of electrons are NaL, that is finding the total charge Q. The charge of an electron is small e. Total charge Q equal to, if the number of electron is 1, the charge is small e. But here the number of electron is not 1. The number of electron is taken as NaL. Therefore, if the number of electrons are NaL, removing the words, we will get the formula for the total charge Q equal to N capital A, small l and small e, that is NaLe. We have got the equation for the total charge Q. Then we have to find the equation for T, so that we can divide the total charge by time. How can we get the equation for the total time T? That is, we know that the time T equal to distance by velocity. Here the distance represents the length of the conductor. The length of the conductor is taken as small l. Here the velocity represents the drift velocity of the electrons. We know that for the time t equal to distance by velocity, the total time t equal to length of the conductor by drift velocity. Therefore, T equal to L by Vd. Now we have got the equation for the total charge Q as well as to the total time T. If we substitute both these values in the equation I equal to Q by T, we will get the formula for the current. We are writing again the formula for the current, that is I equal to Q by T. If we substitute NaLe in the place of Q, and if we substitute L by Vd in the place of T, we will get I equal to NaLe by L by Vd. In the denominator, the fraction L by Vd has come. If fraction comes in the denominator, we should reciprocate and multiple. So if we reciprocate this L by Vd, the Vd should be brought to the numerator. So we will get the equation for the current as NaLe Vd by L. If we cancel the length L placed in the numerator and the denominator, we will get the equation for the current as NAEVD. What is N? Number of electrons per unit volume. What is capital A? The cross-sectional area of the conductor. What is small e? The charge of an electron. What is Vd? The drift velocity of the electrons. So that the formula for the current relating drift velocity, number of electrons per unit volume, cross-sectional area and the charge of the electron is I equal to NAEVD. From this formula, we can also get the formula for the drift velocity. Interchange the sides, we will get NAEVD equal to I. Therefore, the drift velocity Vd equal to I by NAE. So, from this formula for the current, we can also get the formula for drift velocity relating current, number of electrons per unit volume, cross-sectional area of the conductor, charge of the electron. That is drift velocity equal to I by NAE. My dear students, in this video, we have derived the formula for the current. That is I equal to NAEVD. If this video is really beneficial to you, you can share with your friends, relatives and classmates. You can also subscribe my channel. If you want to know all knowledge in this chapter, I appeal to the students to see all my videos. My dear students and parents, in this video, we are going to derive the formula to the drift velocity in the chapter current electricity in the subject physics to the +2 Cbse and IIT students. By God's grace, my educational videos are available in YouTube to 10th Cbse, +1 Cbse, +2 Cbse, NEET and IIT students in the subjects mathematics, physics, chemistry, zoology and botany in English language. We know that the formula for the velocity is acceleration into time. That is velocity v equal to acceleration small a into time t. V equal to at. We also know that the formula for the velocity equal to distance by time. But here we are not selecting that formula. That is velocity equal to distance by time. The reason is when the electrons are flowing in a conductor, they collide with the other electrons, positive ions, heavy fixed ions. After collision, they emerge with the same speed, but the direction is random. Since the direction of the electrons is random, the average velocity of the electrons is 0. So how can we get the average velocity, that is drift velocity of the electrons? When we apply the electric field, now the electrons are accelerated. That is, the electrons are drifted in a particular direction. So we will get the average velocity of the electrons at present. Since the electrons are accelerated, applying the electric field, we are taking the formula containing acceleration. Then Here the time is denoted by not t but tau. Tau means average relaxation time of the electrons. When the electrons are colliding, the collisions between the electrons does not occur at a regular time. The collisions also occur in random times. After the collision of electrons, the direction of the electrons is random. Here the collision between the electrons is also random. It does not occur at regular intervals. So that let us denote this time, that is the relaxation time, as tau. So that we are taking as the time as tau. So the formula for the drift velocity now becomes as drift velocity Vd equal to acceleration small a into average relaxation time tau. Vd equal to a into tau. Then we are going to write the acceleration relating the force and mass, because we know that the formula for the force is mass into acceleration. From that formula we can get the formula for acceleration as force by mass. That is, we know that force equal to, that is capital F equal to mass small m into acceleration a. That is capital F equal to m into a. Therefore, what is a? A equal to F by m. Now we are getting the expression for acceleration as capital F by m. If we substitute capital F by m in the place of acceleration in the equation, velocity, that is Vd equal to acceleration into tau, now the equation for drift velocity becomes as F by m into tau. So initially we are getting the equation for drift velocity as acceleration into tau. Now we are substituting F by m, that is capital F by m, in the place of a. Now we are going to substitute capital E into small e in the place of force, because here the force is the electric force, that is the total electric force. We are going to write this total electric force capital F as capital E into small e. What is capital E? We know that capital E is the electric field. What is electric field? Electric field is nothing but the force experienced by a unit positive charge. Here the force is not experienced by a unit positive charge, but the force is experienced by a charge of an electron. So that we are multiplying the electric field with charge of an electron small e. So we are getting F equal to capital E into small e. After getting the expression capital F equal to capital E small e, we are going to substitute this capital E into small e in the place of capital F in the equation Vd equal to F by m into tau. If we substitute, we will get the equation as drift velocity equal to capital E small e by m into tau. This is the equation for drift velocity relating capital E and tau. What is small e? E is the charge of an electron. What is the charge of an electron? The value of charge of an electron is 1.602 into 10 to the power of minus 19 coulomb. What is small m? Small m is the mass of an electron. What is the value of mass of an electron? The value of mass of an electron is 9.11 into 10 to the power of minus 31 kilogram. So, small e, that is charge of an electron, small m, that is mass of an electron, are constant. Hence, if we know the value of electric field and average relaxation time, we can find the drift velocity. There is also another formula for the drift velocity, that is drift velocity Vd equal to I by NAE. Here I is the current, N is the number of electrons per unit volume, capital A is the cross-sectional area of the conductor taken, the E is the charge of an electron. So, in the sum, if they are giving the value of current and cross-sectional area of the conductor and also the number of electrons per unit volume, we can select the formula for drift velocity, that is Vd equal to I by NAE. The another formula for drift velocity relating current, number of electrons per unit volume, area, charge of an electron, that is Vd equal to I by NAE. You can see the derivation of that formula in a separate video. In this equation, drift velocity equal to capital E small e by m tau. This E tau by m is the mobility. What is mobility? Mobility is also drift velocity. So what is the difference between mobility and the drift velocity? Mobility is the drift velocity when one unit electric field is applied. Therefore, the difference between mobility and the drift velocity is, in the case of drift velocity, more than one unit electric field will be applied. Both are drift velocity. So if we divide the drift velocity Vd by capital E, that is electric field, we will get the drift velocity per unit electric field, that is small e tau by m. This formula is arrived from this formula. Therefore, the formula for mobility Vd by E equal to E into tau by m. My dear students, if this video is really beneficial to you, you can share this video with your friends, relatives and classmates. You can also subscribe my channel. If you want to know all knowledge in this chapter, I appeal to you to see all my videos. My dear students and parents, in this video we are going to find the drift velocity of the electrons in the chapter current electricity in the subject physics to the +2 Cbse and IIT students. By God's grace, my educational videos are available in YouTube to 10th Cbse, +1 Cbse, +2 Cbse, NEET and IIT students in the subjects mathematics, physics, chemistry, zoology and botany in English language. You can see this fact on the board. Let us move to the sum. Estimate the average drift velocity of conduction electrons in a copper wire of cross-sectional area 1 into 10 to the power of minus 7 meter square carrying a current of 1.5 ampere. Assume that each copper atom contributes roughly 1 conduction electron. The density of copper is 9 into 10 to the power of 3 kilogram per meter cube and its atomic mass is 63.5 atomic mass unit. In the sum, it is stated that a copper wire has been taken. The cross-sectional area of the copper wire is given as 1 into 10 to the power of minus 7 meter square. It is also stated that the current flowing through the copper wire taken is 1.5 ampere. 1.5 ampere. Moreover, the other information given are density of the copper. The density of the copper is given as 9 into 10 to the power of 3 kilogram per meter cube. Its atomic mass also has been provided. That is, the atomic mass of copper is given as 63.5 atomic mass unit. We know that there are two formulae we have studied to find the drift velocity, that is Vd. What are they? The one formula to find the drift velocity is capital E small e by m tau. What is capital E? Capital E is nothing but electric field. What is small e? Small e is the charge of an electron. What is m? M is the mass of an electron. What is tau? It is the average relaxation time. In this sum, the electric field is not provided. The average relaxation time has not been provided, so that we cannot select that formula. The another formula we have learned for the drift velocity is drift velocity Vd equal to I by NAE. That formula has been selected. We have to find the drift velocity Vd. The current is given in the sum. It is stated that 1.5 ampere current is flowing in the copper wire taken. So we can put the tick mark for the current. Cross-sectional area of the copper wire taken is stated as 1 into 10 to the power of minus 7 meter square. So put the tick mark for the area. We know that our God has given the charge of 1.602 into 10 to the power of minus 19 coulomb of charge with 1 electron. So that we can also put the tick mark to charge of an electron. So what is the information left in the sum to be given? The number of electrons per unit volume is not provided in the sum. That is, small n has not been supplied in the sum. We have to find the number of electrons per unit volume, that is small n, from the information given in the sum. I can straight away write the formula for drift velocity and substitute the data given and get the result. But I am not doing so. The reason is, at this juncture, if we know the history of getting this formula, it will be most meaningful not only most meaningful to the students, but also it will be understandable. This formula is derived from the first formula for the current, that is I equal to Q by T, that is current equal to charge by time. Charge is denoted by the letter Q and the time is denoted by the letter T. Let us consider the number of electrons per unit volume is small n. Let n be the total number of electrons per unit volume. Per unit volume. We are also considering the total volume as V. The total volume, that is capital V, is written as area into length. What is the area here? The area is the cross-sectional area of the conductor taken. What is L here? L is the length of the wire. We know that volume equal to area into height. In this case, we are taking area into length. So that is the total volume. Now we are going to find the total number of electrons. If the volume of the wire is 1 unit, the number of electrons flowing in the wire is taken as small n. Here the volume of the wire taken is not considered as 1 unit. It is considered as capital AL, that is area into length, that is cross-sectional area of the wire into length. So that we are multiplying with AL. So we will get, if we remove the words, we will get this is N, this is AL, so that the total number of electrons equal to NAL. Now in our hands, we are having the formula to find the total number of electrons. But we don't need the total number of electrons. We need the formula for the total charge. How can we get the total charge? As we already stated, the charge of 1 electron, that is the charge of 1 single electron, is 1.602 into 10 to the power of minus 19 coulomb. The charge of an electron is denoted by the letter small e. So if we multiply NaL with E, we will get the formula for the total charge. The charge of 1 electron equal to E. If the number of electron is 1, the charge is E. Here the number of electron is not 1. The formula for the total number of electrons flowing in the wire is calculated as NaL. So that if we multiply this with the NaL, we will get the total charge. Thus, we have got the formula for the total charge Q equal to NaLe. NaLe. Then we are again writing the formula for the current. I equal to Q by T. We know that time T equal to distance by velocity. So T equal to, what is the distance? Here the distance represents the length of the wire, that is small l. So that small l by velocity. Here the velocity is a drift velocity. So now in our hands we are having the formula for Q and also the formula for T. If we substitute these two formulae in the equation I equal to Q by T, we will get the formula for the current, that is capital I. Substituting Q equal to NaLe and T equal to L by Vd, the formula for the current I equal to NaLe by L by Vd. In the denominator, the fraction has come. If fraction has come in the denominator, it should be reciprocated and multiplied. So if we reciprocate, the VD should be brought to the numerator. If we cancel the L in the numerator and the denominator, we will get the formula for the current as I equal to NAEVD. From this formula, we can get the formula for the drift velocity VD. If we interchange the sides, we will get NAEVD equal to I. Therefore, VD equal to I by NAE. What we understand on seeing the formula for the current, that is NAEVD, the current depends upon the number of electrons available in the given wire, that is NAE. These are the total number of electrons available in the wire. In order to get large current, the number of electrons available in the wire taken should be greater. Not only the number of total electrons, but also the electrons should flow with greater drift velocity. So, the current we are getting depends on the number of electrons available in the wire and also the drift velocity of the electrons. Then, what is drift velocity? Drift velocity is the velocity with which the electrons are drifted towards a positive terminal when the electric field is applied. What is drift velocity? It is the velocity with which the free electrons are drifted towards the positive terminal when an electric field is applied. Drift velocity is also called average velocity. When the electrons are flowing in a wire, they collide with other electrons, positive ions, and also the walls of the conductor. After collision, the electrons emerge with the same speed but in random direction. Since the electrons are flowing in random directions, the average velocity of the electrons is 0. So how can we get the average velocity of the electrons? When we apply the electric field, now the electrons will be drifted. Now the electrons will move at a particular direction. At this instance only, we will get the average velocity. Then do you know what is the direction of the drift velocity of the conduction electrons? The direction of the drift velocity of the conduction electrons is opposite to the direction of the electric field. So it is not in the direction of the electric field. The direction of the drift velocity of the electrons is towards the increasing potential. On seeing the diagram, you can understand that how the electrons are flowing in random directions before applying the electric field, that is capital E. You can also see the diagram to understand the direction of the drift velocity of the conduction electrons. The diagram is also provided for your reference. So far we have seen the history of obtaining the formula for drift velocity as I by NAE. That is drift velocity equal to I by NAE. As already stated, the current is given, that is 1.5 amperes. The area of that is the cross-sectional area of the copper wire taken is given as 1 into 10 to the power of minus 7 meter square is given. The area is given we know the charge of an electron. What is the charge of an electron? The charge of the electron is 1.602 into 10 to the power of minus 19 coulomb. Here it is taken as 1.6 into 10 to the power of minus 19 coulomb. So we have to find the number of electrons per unit volume, that is small n. The method of finding number of electrons per unit volume. In order to find the number of electrons per unit volume, we know the concept of mole. 1 mole can be expressed in terms of mass, in terms of volume, in terms of number of molecules or number of atoms or number of electrons, etc. And 1 mole can be expressed in terms of charge. That is concept of mole. If we express 1 mole in terms of mass, 1 mole contains 1 molar mass or 1 atomic mass. That is 1 mole contains 1 molar mass or 1 atomic mass. If we express 1 mole in terms of volume, 1 mole contains 22.4 liters volume. 1 mole contains 22.4 liters volume. If we express 1 mole in terms of number of molecules or number of atoms or number of electrons, etc., 1 mole contains 6.023 into 10 to the power of 23 number of electrons. This 6.023 into 10 to the power of 23 number of electrons is the Avogadro number. 1 mole contains 6.023 into 10 to the power of 23 number of molecules or number of atoms or number of electrons, etc. This number is the Avogadro's number. Then if we express 1 mole in terms of charge, 1 mole contains 96,500 coulomb of charge. This 96,500 coulomb of charge is nothing but 1 Faraday. 1 mole contains 96,500 coulomb of charge, that is 1 Faraday. There are 5 data here: mole, mass, volume, number of electrons and the charge. Of these 5 data, if we know any data, we can change into any other data. In this sum, we are going to apply 1 atomic mass contains 6 into 10 to the power of 23 number of electrons. 1 atomic mass is nothing but 1 mole. 6.023 into 10 to the power of 23 number of electrons is nothing but 1 mole. So that we can equate 1 atomic mass and 6 into 10 to the power of 23 number of electrons. We are going to apply this information in this sum. What is the valence electron in the case of copper atom? In the case of copper atom, the valence electron is 1. Here, 1 electron means not 1 single electron, 1 mole of electrons. That is 6.023 into 10 to the power of 23 number of electrons. How we are saying in the case of copper atom, the valence electron is 1. You know that the atomic number of copper atom is 29. What is the electronic configuration? In the case of the copper atom, the maximum number of electrons revolving in the first orbit are 2. The maximum number of electrons revolving in the second orbit are 8. Maximum number of electrons revolving in the third orbit are 18. So totally 28 electrons we have put in 3 orbits. So the remaining electron is 1. We are going to put this 1 electron in the last orbit, that is in the valence orbit, that is in the outermost orbit. So the valence electron is 1. What is the electronic configuration? 1s2, 2s2, 2p6, 3s2, 3p6, 3d10 and 4s1. Also know the atomic mass of one copper atom. In the sum also they have given the atomic mass of copper, that is 63.5 atomic mass unit. Therefore, if we express this atomic mass in gram, we can say that the atomic mass of the copper is 63.5 gram. We have already discussed in one atomic mass the number of electrons are 6 into 10 to the power of 23. So in this case, the atomic mass of one copper atom is 63.5 gram. If the mass of the copper is 63.5 gram, the number of electrons are 6 into 10 to the power of 23. If the mass of the copper is 63.5 gram, the number of electrons are 6 into 10 to the power of 23. In this sum, the mass of the copper is not 63.5 gram. This 63.5 gram is the atomic mass of one carbon atom. In the sum, the mass of the copper is given as 9 into 10 to the power of 3 kilogram per meter cube. If we convert this 9 into 10 to the power of 3 kilogram into gram, we will get 9 into 10 to the power of 6 gram. So that we are writing 9 into 10 to the power of 6 gram. So if we remove the words, we will get for the number of electrons per unit volume as 6 into 10 to the power of 23 by 63.5 into 9 into 10 to the power of 6. Therefore, the number of electrons per unit volume N equal to 8.5 into 10 to the power of 28 per meter cube. Now in our hands, we are having all required for data. That is the value of current, the cross-sectional area of the wire taken. We know the charge of an electron. We have determined the number of electrons per unit volume as 8.5 into 10 to the power of 28 per meter cube. So if we substitute all these four data in the equation Vd equal to I by NAE, we will find the drift velocity of the electron. In the place of I, we are substituting 1.5 amperes. In the place of N, we are substituting 8.5 into 10 to the power of 28. In the place of cross-sectional area, we are substituting 1 into 10 to the power of minus 7. In the place of charge of an electron, we are substituting 1.6 into 10 to the power of minus 19. So the equation for a drift velocity becomes as 1.5 by 8.5 into 1.6 into 10 to the power of 2. Because if the bases are same, the powers can be added. If we bring the 10 to the power of 2 to the numerator, it will become as 10 to the power of minus 2. If we calculate this data, we will get the drift velocity as 1.1 into 10 to the power of minus 3 meter per second. If we say in millimeter, the drift velocity calculated is 1.1 millimeter per second. So my dear students, hereafter in your hands, the cross-sectional area of the conductor, the current flowing through the conductor, and the number of electrons per unit volume are given. Definitely you can find the drift velocity, that is average drift velocity of the electrons. If you want to know all information in this chapter, I appeal to you to see all my videos. If this video is really beneficial to you, you can share this video with your friends, classmates and relatives. You can also subscribe my channel. My dear students and parents, in this video we are going to see whether the given binary operations are commutative and associative in the chapter Relations and Functions in the subject Mathematics to the +2 Cbse and IIT students. You can see this fact on the board. By God's grace, my educational videos are available in YouTube to 10th Cbse, +1 Cbse, +2 Cbse, NEET and IIT students in the subjects Mathematics, Physics, Chemistry, Zoology and Botany in English language. The given sum is, let star be a binary operation on the set Q of rational numbers. Find whether the given binary operation A star B equal to A minus B are commutative and associative. In this sum, a set has been given. In this set, they are stated that only the rational numbers should be taken. That is Q of rational numbers. We know that rational numbers are denoted by the letter capital Q. What are the rational numbers? Fractions are the rational numbers. The rational numbers include natural numbers, whole numbers, positive integers, negative integers and fractions. So we can take the natural numbers, or we can take the whole numbers, or we can take the positive integers, or we can take the negative integers, or we can take the fractional numbers. The binary operation is provided as A star B equal to A minus B. What is binary operation? In the binary operation, a set is given. In this set, some elements will be given. Of these elements, we can take any two elements and we should perform the binary operation as prescribed in the sum. In this case, the binary operation is prescribed as A star B equal to A minus B. We should subtract B from A. Then we will get a result, that is answer. Definitely the result obtained should also be included in the given set. The result obtained should not be outside the given set, that is outside the elements of the given set. These are the conditions. What is binary operation? It is the operation of two elements of a set A such that the resulting element is also in the set A. Then what is commutative property? If we interchange the positions, that is the orders of the numbers, the result should not be changed. What is commutative property? If we interchange the order, that is position of the numbers, the result should not be changed. Suppose we are taking two numbers 3 and 6, we are adding these numbers. In the first position, the number 3 is placed. In the second position, the number 6 is placed. So the result obtained is 9. In this expression, in the first position, we are writing the number 6, and in the second position, we are writing the number 3. It means that in the place of 3, we have written 6 and in the place of 6 we are writing 3. Even though we are interchanging the position of the numbers, that is the first position is changed into second position and the second position is changed into first position. Even though we are changing the position of the numbers, here also the result got is 9. So the result is not changed. Therefore, the commutative property is satisfied in this addition operation. Then we are going to one multiplication operation. In this multiplication operation, we are going to take two numbers 4 and 5. In the left side expression, in the first position, the number 4 is placed. In the second position, the number 5 is placed. The operation is multiplication. If we multiply these two numbers, we will get the result 20. Now, in this case, in the first position, the number 5 is written. In the second position, the number 4 is written. The operation is also multiplication. It means that in the position of 4, we are writing 5, and in the position of 5, we are writing 4. That is, we are interchanging the positions. Even though we are interchanging the positions, the result is the same. The result is not changed. Here also 5 into 4 equal to 20. Therefore, in the case of multiplication operation also, the commutative property is satisfied. Hence, we conclude that in the case of addition operation as well as in the case of multiplication operation, the commutative law is satisfied. What are the 4 fundamental mathematical operations? The 4 fundamental mathematical operations are addition, subtraction, multiplication and division. Then we are going to see what is associative property. In whatever way we are grouping the numbers, the result will be the same. The result should not be changed. Wherever we put the parenthesis, what is associative property? In whatever way we are grouping the numbers, the result should not be changed. Wherever we put the parenthesis. Suppose we are taking 3 numbers 4, 5, 6. First of all, we are grouping the first 2 numbers, that is 4 and 5. And the operation is addition operation. So if we group 4 and 5 in the addition operation, that is 4 plus 5 equal to 9. After getting the result in 9, we are adding the number 6. So if we add the number 6, we will get the answer as 15. In this case, we have grouping the first 2 numbers. Then we are going to grouping the second and the third number. That is, we are going to group 5 and 6. The operation is addition operation. If we add 5 and 6, we will get 9. After getting 9, if we add 4 with this 9, the result obtained is 15. So in this case also the result is 15. In this case also the result is 15. Even though in whatever way we are grouping the numbers, the result is the same in the case of addition operation. Therefore, the associative law is satisfied in the case of addition operation. Then we are going to perform the multiplication operation. Here also we are taking the three numbers 4, 5 and 6. First of all, we are grouping the first and second numbers, that is 4 and 5. The operation is multiplication operation. If we multiply 4 and 5, we will get 20. After getting the number 20, if we multiply with 6, we will get the result as 120. In this case, we are going to group second and the third number. In this case, we are grouping the numbers between first and the second. Here we are grouping between the second and the third numbers, because the parenthesis is put between second and third. We know that the data within the parenthesis, that is within the bracket, should be performed first. So that if we multiply 5 with 6, we will get 30. After getting 30, if we multiply that 30 with 4, we will get 120. So in this case also the result is 120. In this case also the result is 120. Therefore, in whatever way we are grouping the numbers, that is we are putting the parenthesis, that is bracket, the result is the same. The result is not changed. Therefore, in this case also, we come to the conclusion the associative law is satisfied in the case of multiplication operation. Therefore, the final conclusion is, in the case of addition operation as well as in the case of multiplication operation, the commutative law and the associative law are satisfied. We can take any numbers from the natural numbers, from the whole numbers, from the positive integers, from the negative integers, and from the fractions. In this case, we are going to take three positive whole numbers, that is 1, 2, 3. This 1, 2, 3 belongs to capital Q, that is a rational number. The binary operation given in the sum is A star B equal to A minus B. So, if we substitute 1 in the place of A and substitute 2 in the place of B, we will get 1 star 2. What will be the result of 1 star 2 as per the binary operation given in this sum? That is A minus B. What is A? The A is taken as 1. What is B? The B is taken as 2. So if we substitute 1 in the place of A and substitute 2 in the place of B, we will get 1 minus 2. What is 1 minus 2? The result is minus 1. So we have got 1 star 2 as minus 1. Then we are going to interchange the position of the numbers. That is, in the position of A, we have written B. In the position of B, we have written A. That is, we have interchanged the positions. That is the order of the numbers. If the commutative law is satisfied, the result should not be changed. In the place of B, we are writing 2. In the place of A, we are writing 1. We are going to perform the binary operation as per the description given in the sum. The binary operation B star A equal to B minus A. In the place of B, we have written 2. In the place of A, we have written 1. Therefore, 2 star 1 equal to, again in the place of B, we are writing 2, and in the place of A we are substituting 1. If we subtract 1 from 2, we will get the answer 1, that is plus 1. In the case of 1 star 2, we are getting the answer as minus 1. Minus 1. In the case of 2 star 1, we are getting the answer as plus 1. Plus 1. Therefore, the result is not same in this case. Hence, we conclude that the commutative law is satisfied in the given binary operation A star B equal to A minus B. Then we are going to verify whether the associative law is satisfied in the given binary operation A star B equal to A minus B. In order to prove the associative law, we are taking 3 numbers, that is 1, 2, 3. First of all, we are grouping the first 2 numbers, that is 1 and 2. We are going to perform the binary operation between 1 and 2. Then after getting the result, we are going to binary operator with 3. So what will be the result of 1 star 2 as per A star B, that is A star B equal to A minus B. In the place of A, we have written number 1. In the place of B, we have written the number 2. If A star B equal to A minus B, what is A star 2? A star 2 is nothing but 1 minus 2. Then what is 1 minus 2? 1 minus 2 is minus 1. This minus 1 is to be binary operated with 3. That is in the place of A. Now we have got minus 1. In the place of B, we have taken the number 3. Therefore, the minus 1 star 3 will become as minus 1 minus 3. What is minus 1 minus 3? Minus 1 minus 3 equal to minus 4. Thus, 1 star 2 star 3 equal to minus 4. Now we are going to group the second and the third numbers, that is 2 and 3. We are well aware that the operation within the bracket, that is parenthesis, should be performed first. In this case, the parenthesis is between 2 and 3. Therefore, if we binary operated 2 with 3, we will get 2 minus 3. What is 2 minus 3? 2 minus 3 equal to minus 1. Then we are going to perform the binary operation between 1 and minus 1. That is 1 star minus 1. What we will get? 1 minus of minus 1. Minus into minus, minus into minus plus. Therefore, 1 plus 1 equal to 2. Thus, 1 star 2 star 3 equal to 2. Here, 1 star 2 star 3 is obtained as minus 4. Thus, 1 star 2 star 3 is not equal to 1 star 2 star 3. Therefore, the given binary operation is not associative. Therefore, the given binary operation is not associative. My dear students, in this way, we can find whether the given binary operation is commutative and associative or not. If this video is really beneficial to you, you can share this video with your friends, classmates and relatives. You can also subscribe my channel. If the students want to gain all knowledge in this chapter, I appeal to the students to see all my videos. My dear students and parents, in this video we are going to learn how we have born. That is, how a child is born by various reproductive events occurring in males and females. In the chapter Human Reproductive System, in the subject Zoology, to the +2 Cbse and NEET students. By God's grace, my educational videos are available in YouTube to 10th Cbse, +1 Cbse, +2 Cbse, NEET and IIT students in the subjects Mathematics, Physics, Chemistry, Zoology and Botany in English language. Various reproductive events are gametogenesis, insemination, fertilization, implantation, gestation and parturition. What is gametogenesis? Gametogenesis is the formation of gametes. What are gametes? Gametes are sperms in the case of males and ovum in the case of females. That is, the formation of sperms in the case of males and the formation of ovum in the case of females are called the formation of gametes. This event is called gametogenesis. Is it enough to form the sperms and ovum in order to give birth? No. After forming the sperms and ovum, the sperms should be transferred into the female genital tract. This event is called insemination. After transferring the sperms into the female genital tract, the fusion of sperms and ovum will occur. This fusion of sperms and ovum occurring in female is called fertilization. Fusion means joining, combining the sperms and the ovum. When the sperm fuses with the ovum, a product is formed. That product is called zygote. All reproductive events are gametogenesis, insemination, fertilization, implantation, gestation, parturition. After forming the zygote, blastocyst is formed, developed and attached to the uterine wall of the female. This event of forming, developing and attaching in the uterine wall of the female is called as implantation. Implantation, blastocyst. Then after the event of implantation, embryo is developed. This development of embryo is called gestation. Gestation. In this gestation, embryo is developed. Finally, there is delivery of the baby. This event of delivery of the baby is called parturition. Parturition. In this event of parturition, the baby is released. That is, the baby is delivered. These are the 6 reproductive events in order to give birth to a child. The next question arises is whether these all reproductive events will occur from the date of the birth. No. These reproductive events will take place only after attaining the puberty. There are remarkable difference between the reproductive events occurring in the case of male and the female. What is that remarkable difference? In the case of male, the formation of sperms continue even in the olden age. But in the case of female, the formation of ovum ceases, that is, stops around the age of 50. Why humans are called viviparous? The humans are called viviparous because humans are sexually reproducing the young ones. Then what is oviparous? The oviparous are laying the eggs and hatching the young ones. Next, very interesting information is, in the case of the male, 1 billion sperms are produced every month. But in the case of the female, only 1 ovum is produced every month. That is, in every menstrual cycle. We, here we means not only students, but also all of us should know about the functions of various systems of our body. Why should we know the functions of various systems in our body? In order to protect our body and health. Without knowing the functions of various systems working in our body, definitely we cannot protect our body and health on our own. Various systems in our body are digestive system, respiratory system, circulatory system, excretory system, nervous system, reproductive system, and also muscular system, skeletal system, and chemical coordination and integration. Various systems: digestive system, respiratory system, circulatory system, excretory system, nervous system, reproductive system, and also muscular system, skeletal system, and chemical coordination and integration. Moreover, if we know the functions of all systems, we can increase our immunity, that is natural immunity, to a greater extent. If we improve the immunity, any microorganisms like virus, bacteria cannot come near to our own body soldiers, such as WBC, that is white blood corpuscles. If we know the functions of all systems and if we know why, where, when the deficiency of any system is occurring in our body, definitely we can rectify that defects and live very happily and healthily. I give 100% assurance. I have taken so many videos in respect of functioning of various systems of our body. If you have time, you can see all my videos and get the benefit of this. My dear students, if you want to know all information in this chapter, I appeal to the students to see all my videos. If this video is really beneficial to you, you can share this video with your friends, relatives and classmates. You can also subscribe my channel. My dear students and parents, in this video we are going to do a word problem in the multiplication of matrices. Thereby we are going to find the gross profit in the chapter matrices in the subject mathematics to the +2 Cbse students. By God's grace, my educational videos are available in YouTube to 10th Cbse, +1 Cbse, +2 Cbse, NEET and IIT students in the subjects mathematics, physics, chemistry, zoology and botany in English language. First of all, let us see the sum. A manufacturer sells the products X, Y, Z in two markets. Annual sales are indicated below. Products X, Y, Z. Market 1 and 2. Market 1 10,000, 2,000, 18,000. Market 2 6,000, 20,000, 8,000. If the unit cost of the above three commodities are ₹2, ₹1 and 50 paise respectively, find the gross profit. In the sum, it is stated that there are two markets, market 1 and market 2. In these two markets, three products are sold. Those three products are given as product X, product Y and product Z. In the case of market 1, the number of X product sold is 10,000 and the number of Y product sold is 2,000 and the number of Z product sold is given as 18,000. In the case of the second market, the number of X product sold is 6,000, the number of Y product sold is 20,000 and the number of Z product sold is 8,000. We have to perform three duties in order to find the multiplication of matrices so that we can find the gross profit using the matrix algebra. What are these three duties? The first duty is we should convert the given data in the form of matrices. After forming the matrices, we should decide whether the multiplication of matrices is possible or not. The reason is we cannot perform the multiplication of matrices to any number of rows and to any number of columns contained in a matrix. There is a condition to perform the multiplication of matrices in the case of number of columns and the number of rows. The third duty is, after deciding the multiplication of matrices is possible, we have to know how can we multiply the row and the column. Thereby we will get the result. Let us proceed to the first duty. What is the first duty? The first duty is writing the given data in the form of matrices. How can we write the given data in the form of matrices? There are two markets. In the two markets, the three products are sold, as we already told. So we can write the number of products sold in the market 1 and in the market 2 as a matrix. Say matrix A. In respect of market 1, we can write the number of products sold. That is the number of products X, Y and Z sold can be written as first row. So this data is written as first row in the matrix A. Then in respect of market 2, the number of products sold, that is X, Y and Z products sold, are written as second row. That is 6,000, 20,000 and 8,000. Thereby we are getting the matrix A. Then we can write the unit price of the products given, that is rupees 2, rupee 1 and 50 paise as a matrix, say B. So if we write the unit cost of the products as a matrix, we will get the matrix B as rupees 2, rupee 1, rupee 0.50. This is the unit price of product X. This is the unit price of product Y. This is the unit price of product Z. So now we have constructed two matrices A and B. In the chapter matrices, we are studying the topics equality of matrices, types of matrices, order of a matrix, addition of matrices, difference of matrices, multiplication of matrices, multiplication of a matrix by a scalar, transpose of a matrix, inverse of a matrix using elementary operation, and symmetric and skew symmetric matrix. In this sum, we are studying the multiplication of matrices. The second duty is whether the multiplication of matrices is possible in the matrices formed. There is a condition to perform the multiplication of matrices. The condition is the number of columns of a matrix should be equal to the number of rows of another matrix. Then only we can perform the multiplication of matrices of two given matrices. That is condition for multiplication of two matrices A and B. The number of columns of matrix A should be equal to the number of rows of matrix B. In the case of matrix A, there are three columns. This is the first column, this is the second column, this is the third column. So there are three columns in the matrix A. In respect of matrix B, there are three rows. This is the first row, this is the second row, this is the third row. So as per the condition, the number of columns in this case are equal to the number of rows. Hence, in this sum, we can proceed the multiplication of matrices. The third duty is how to perform the multiplication of matrices. In order to perform the multiplication of matrices, there is a procedure. That procedure is, at a time, we should take one row and one column. The first element of the row should be multiplied with the first element of the column. The second element of the row should be multiplied with the second element of the column. The third element of the row should be multiplied with the third element of the column. This is the procedure to perform the multiplication of matrices. After getting the product, we should add all the products. Thereby, we will get the result. Procedure to find multiplication of matrices. Elements of product are obtained by multiplying each row of matrix A with each column of matrix B element wise and adding them. We have already seen in the previous videos, in the case of equality of matrices, in the case of addition of matrices, and in the case of difference of matrices, the order of the both matrices taken should be the same. In the case of multiplication of matrices, that condition will not apply. The order of the both matrices need not be same. But however, at the same time, the number of columns of the matrix A should be equal to the number of rows of matrix B, so that we can get the multiplication of matrices A, B. The order of the first matrix is 2 by 3 because there are 2 rows and 3 columns. The order of the matrix B is 3 by 1. The reason is there are 3 rows and 1 column. While writing the order of a matrix, we should write the number of rows first and the number of columns second. So after performing the multiplication of matrices, we will get the matrix of the order of 2 by 1. The reason is this column 3 and this row 3 will be cancelled, so that the remaining is 2 by 1. Now we will take the first row of the matrix A. The first row of the matrix A is taken, and we will take the first column of the matrix. As I already told, at a time we should take 1 row and 1 column, so that we can get the multiplication of matrices. Now we are going to find the multiplication of matrices. This first row represents the number of products sold in market 1. That is the number of products S, Y, Z sold in the market 1. So what is the first element of this row? The first element of this row is 10,000. What is the first element of this column? The first element of this column is 2. So we have to multiply the first element of this row with the first element of this column. Hence we will get 10,000 numbers into rupees 2. Then we are going to multiply the second element of the row with the second element of this column, so that we will get 2,000 numbers into rupee 1. After that, we are going to multiply the third element of this row with the third element of this column. What is the third element of this row? 18,000 numbers is the third element of this row. What is the third element of this column? The rupee 0.50 is the third element of this column. If we multiply both, we will get 18,000 numbers into 0.50. If we multiply 10,000 numbers with rupees 2, we will get rupees 20,000. If we multiply 2,000 numbers with rupee 1, we will get 2,000 rupees. If we multiply 18,000 numbers into 0.50, we will get rupees 9,000. If we add these three terms, we will get 31,000. Then we are going to calculate the total cost of the products sold in market 2. For that reason, we are taking the number of products sold in the second market. That is, the second row of matrix A is taken. 6,000 numbers, 20,000 numbers, 8,000 numbers. This 6,000 numbers is the number of X product sold. This 20,000 numbers is the number of product Y sold. This 8,000 numbers is the number of Z product sold. With this number, we are going to multiply this column. That is, one row is taken and one column is taken. This rupees 2 is the unit cost of the product X. This rupee 1 is the unit cost of product Y. This rupee 0.50 is the unit cost of product Z. So when we multiply the number of products sold with the unit cost, we will get the total cost of the products sold. As we already discussed, the first element of this row should be multiplied with the first element of this column. That is 6,000 into 2. Then the second element of this row should be multiplied with the second element of this column. Thereby we will get 20,000 into 1. Third element of this row should be multiplied with the third element of this column. Hence we will get 8,000 into 0.50. This is the number of products sold. This is the unit cost of the product. So if we multiply 6,000 with 2, we will get 12,000. If we multiply 20,000 with 1, we will get rupees 20,000. If we multiply 8,000 numbers with rupee 0.50, we will get rupees 4,000. If we add these three terms, we will get rupees 36,000. This is the total cost of the products sold in the market 2. Now we are going to find the gross profit for the number of products sold. Now we have obtained the total cost of the products that is X, Y, Z products in the market 1 as rupees 31,000. Similarly, we have obtained the total cost of the all three products, that is X, Y, Z in the market 2 as 36,000 rupees. If we write these two costs, that is these total two costs, we will get the matrix of the order of 2 by 1. Then we are going to find the gross profit in market 1 and the gross profit in market 2. Finally, we are going to find the total gross profit in both the markets. We have determined the total sale value of products X, Y, Z in market 1 as rupees 46,000. This figure is obtained in the previous video. In this video, we have determined the total cost of the all three products in market 1 as rupees 31,000. So what will be the gross profit in market 1? Hence the gross profit in market 1 equal to rupees 46,000 minus rupees 31,000 equal to rupees 15,000. That is total sale value minus total cost. Then we are going to find the gross profit in market 2. We have determined the total sale value of products X, Y, Z in market 2 as rupees 53,000. This figure is available in the previous video. In the previous video, we have found the total sale value of market 1 and the total sale value of market 2. In this video, we have determined the total cost of the products X, Y, Z in market 2 as rupees 36,000. Hence the gross profit in market 2 equal to total sale value minus total cost. That is rupees 53,000 minus rupees 36,000. Hence the gross profit in market 2 is rupees 17,000. Therefore, the total gross profit in both the markets equal to 15,000 plus 17,000 equal to rupees 32,000. In this way, using the matrix algebra, we have determined the total gross profit gained by the manufacturer. My dear students, if you want to know all information in this chapter, I appeal to the students to see all my videos. If my video is most beneficial to you, you can share this video with your friends and your classmates. You can also subscribe my channel. My dear students and parents, in this video we are going to do a word problem in the multiplication of matrices, and we are going to find the total sale amount. In the chapter matrices, in the subject mathematics to the +2 Cbse students. By God's grace, my educational videos are available in YouTube to 10th Cbse, +1 Cbse, +2 Cbse, NEET and IIT students in the subjects mathematics, physics, chemistry, zoology and botany in English language. Let us see the sum. A manufacturer sells the products X, Y, Z In two markets, annual sales are indicated below. Market products. In the market 1, the products